as you wish, as well. I can do in English, although I translate everything in Italian, so I did an extreme work. Okay, so today all in English, this session, and so we start with the European Commission. Hello, Alice? Hello, hi Alice. So the floor is yours. We are late.
Hello.
Hello. You have 20 minutes, and then we will have some questions if you have any question. Okay, thank you so much.
Perfect. Let's start. I'll share my screen so that you see the presentation. Okay, can you see my screen properly?
Yes, Alice, go ahead.
Perfect. So, hello everybody. I'm Alice Guedel from the European Commission. I'm part of the Finance DG and working in the Digital Finance unit. So today I'm going to be presenting a project that we have, which is the Data Hub. And basically it's a project of exchanging data using synthetic data. So first I will present the context of the Data Hub and this initiative and why we decided to use synthetic data. And then my colleagues Andrea and Erica from JRC, which are also part of the commission, will be presenting a bit more in detail what they're working on in terms of synthetic data. So before I dig into the Data Hub, I wanted to give you a bit of context on why we decided to build this project. So we've noticed in the latest years that sometimes the connections between the startups and the national regulators are a bit poor. So we wanted to find a way to unite and to connect a bit more these national supervisors and the startups, so that innovation would be also in line with what's happening on the regulatory side. So basically, we decided to do this connection through data sharing. So here on this first slide, you can see the link to the digital finance platform, which is the place where we have the Data Hub. So if you want, you can have a look at it right now, or otherwise, if we have time at the end, I will show you a short demo. So to start with, what is the Data Hub? The Data Hub is a new project designed to give innovative financial firms access to synthetic supervisory data for the purpose of testing new products and applications and training AI and ML models. So basically, we decided to build a repository where supervisors would share their data that they hold, and startups, fintechs, would be able to access this data to test their own products. So basically, the Data Hub would serve as a point of intermediation and data exchange between innovative firms and national competent authorities. And I don't know if you have heard already about sandboxes and innovation hubs, you probably have. But basically, this Data Hub initiative is in line with sandboxes and innovation hubs initiatives, but it complements it in the sense that it doesn't replace it. It's not a similar project, but it complements what's already been done in testing environments, so in the sandboxes, innovation hubs, and even some initiatives around cross-border testing. So this was a quick overview of what the Data Hub is. Of course, the reason why we also decided to do this Data Hub is because there's a new policy, which is called the European Data Strategy, that encourages the reuse of certain public sector data that cannot be made available as open data. So basically, it's through this strategy that we decided that we would be building this Data Hub, because in any case, at some point, public data will be available for companies and for academics to use. But since it's very sensitive data, so far, we didn't really know how we could kind of share this data in a compliant way. So that's why I'm going to the next slide, which is what type of data would be available. Because it's not only having the supervisors agree to share data, it's also finding a way to make this data available in a compliant way. And so this is why we decided to use synthetic data. So, as I said, to ensure the compliance with confidentiality requirements, the European Commission, together with supervisory authorities, has decided to build a data hub using synthetic data. And for national supervisors, it's also using synthetic data is also a way to participate in the data hub project without having to make the real data they hold accessible to any third party. So this is probably, you probably know already what synthetic data is. I will give a short definition just in case. So synthetic data is artificial data that is generated from the original data and is trained to reproduce the characteristics and the structure of the original data. So this is a definition that is commonly used, but other definitions exist as well. So since it's also a recent technology, it's possible that there might be some discussions around the real definition of synthetic data. I use this one to make it as simple as possible, but of course, I understand that there are discussions around the definition. So then there's a short image that shows what synthetic data looks like, and it's a good way to show that it's not exactly the original data, so the points are in different places, but the structure globally stays the same. So to do this project, this data project, we decided to work with two contractors, one that will be taking care of all the data services, which is called Net Company. And we're also working with a synthesization software. So this software is called synthesize.io. And this software we are using for the supervisors to be able to download the software on their premises, synthesize the data directly there, and then they would be able to decide which synthetic final data sets come out of their premises. So in terms of like compliance and security, like the original data never moves from the servers of the supervisor. And this method makes it possible to generate synthetic data that offers the necessary level of anonymization while preserving the characteristics of the original data that make it relevant for testing purposes. So as I mentioned at the beginning of the call, my colleagues from JRC are here. JRC is the research direction of the European Commission, and we are working very closely with them so that on their side they can also test the methodology of the synthesization software. So before we share this software with any supervisor, here internally at the Commission, we have a team that is dedicated to testing this software. So now I will leave the floor to my colleague Andrea, and thank you very much for listening to the presentation.
Okay, thanks Alice, and good morning to everyone. I'm about to share the screen. Just let me know if you see it.
Andrea, we can see it.
Yes, we can see it.
Yes,
okay.
Thank you.
So, as Alice said, I work for the Joint Research Center, which is the technical arm of the Commission in terms of developing tools and analysis to support the Commission policies.
Andrea, sorry if I
Yes.
stop you here, because we don't see anymore the screen.
You don't see?
No.
Okay.
Let's see.
Just a second.
Okay, perfect. Thank you.
Okay, so I leave it in this modality. Okay, so I was saying we are the technical arm of the Commission. We have 6 sites across Europe dealing with different aspects of the research and the needs of the Commission. And we collaborate with different DGs for different reasons and different also European institutions. We also have a good connection with academic partners and international organizations. So we want to offer, high level of research to support the action of the European Commission. So now talking about the problem of the synthesization of data. So as Alice said, actually, I mean, we don't test the software because we test the result of the software. And as Alice said, I mean, there is a problem of have some kind of fidelity with the original data together with some privacy restriction. And so we have to find a balance in terms of the result of the synthesization with these two different aspects. So what is the real need for synthetic data? I mean, we can amplify small data set. They are fast to generate, so it can be used to test models, methods, algorithms, and then they should be able to preserve privacy. So the application of synthetic data can be very, very, very different with respect to different goal and desired analysis they one want to take action on. And this is the structure of the process of desynthesization. So we have to, I mean, be sure that we prepare the original data in the proper way. We have to be sure that there are the companion of metadata together with the original data. And then there is the point of building a generative model to train the original data and then to get the synthesization of them. The main point is to evaluate the output. So there are different aspects one has to take into consideration. The first one is the statistics of the solution provided by the software that synthesizes the data. Statistics means that we have to take into consideration both univariate and bivariate statistics, correlation, always together with the point of the privacy, which is probably the most important part because it's very difficult to be able to properly assess the level of privacy that one wants to achieve. Now, I mean, there is a very long discussion about the difference between machine learning and classical statistics. I mean, I don't want to go over this long story of discussion among the scientific community. The main point that I want to make with this slide, which is very wordy, but I mean, the real point is that with synthetic data, we have a wealth of information that can be used once the synthetic data are properly constructed, built, to train models that otherwise cannot be feasible with real data. So we have to be aware that there is a new way to assess the quality of method, models, algorithms using synthesization. But to get there, one has to somehow assess the quality of the synthesization process. So we run on the basis of the software that the Commission is using to provide the stakeholder, the innovative firms, data to train their model to assess the quality of the products. So we run a couple of exercises on the basis of several data samples, but I will talk only about one of them, which is based on data extracted from Orbis Focus, which is a data provider that gives information on banks' balance sheets. So we have an original sample of more than 3,000 banks. Usually this data comes with a lot of missing values in different categories, in different variables. Then we run the synthesization process both on the original data with missing values and the original data without missing values, just to assess the quality of the results. There were, the most important variable of interest are listed here. There is no need I go through it. One important thing that I want to mention is that for this kind of data, but that can be also for different situations, there are some rules that the synthetic data should be compliant with. For example, the accounting rules for banks. Total assets should be equal to total liability plus equity, or if there is already some ratio, the ratio should be equal to what the ratio is about. And so in our analysis, we did the synthesization imposing rules, or in another case, without any imposition. Now, in the next few slides, I will show you the result of this exercise and the analysis we did on the results. So here you can see the distribution, so the univariate distribution for some of the variables that we try to synthesize. You can see that, in terms of distribution, the result of the synthesization is quite good. There are few exceptions that are highlighted in the graphs, both in terms of the overall distribution, but also in terms of outliers. You can see on the right side of the panel. One point is that if you go to the panel on the bottom right, where there is the synthesization without imposing any rules, there are some exceptions, like the leverage. There is some equity which is very, very negative because we don't impose any kind of condition on them. So it's important to keep in mind that rules should be imposed on the algorithm. That's another way to look at the result. An example of bivariate analysis with a scatter plot. You can see that there are some differences. So the main point, I don't know, sorry. So the main point now is, okay, in terms of so in terms of overall distribution, they look pretty nice. Okay, so the synthetic data are able to resemble the original data. Now, another type of analysis, okay, let's look at the single banks in terms of, for example, taking the largest bank in the 3 samples, or the 75 percentile, or the median. Sorry, people are calling me. So you can see that there are differences, and this is good in terms of privacy, because despite the fact that whenever you look at the overall distribution, you can see on the top that the number for the total asset, equity, and risk-weighted assets are more or less the same, with the exception of the last value for the risk-weighted asset. But then when you mix them in a single bank, there are differences. So this is good because, it preserves some kind of privacy property. So it's very difficult to see which kind of bank we are talking about when we do the synthesization. And this is also possible to see when you look at the correlation matrix. The correlation matrix for the two data, the original data set and the synthesized data set, if you look at them all together, they look pretty similar. Then when you go for the specific case, you see that there are some differences. So the main point is that synthesization overall does a pretty good job in preserving the characteristic of the overall distribution. There are differences when you go at the single case, and that's good for the privacy, because that's one of the main points. Now, how these two aspects, which seems to conflict, I mean, which kind of impact they have when you do modeling exercise using synthetic data. And this is the last slide that I want to show you, because, I mean, we have a model that we usually run to assess the state of the European banking sector. It's called Symbol Model. It's a model that has been used by the Commission since probably, I don't know, 15 years, and provides losses in the banking sector. So the output of the model is an estimation of potential losses in the banking sector. So we run this model on the three data sets, the original, the one with no rules, and the one with rules. And the results are pretty good when rules are applied, despite the fact that for the single case, you have different balance among the variables. So it's not true that the largest bank has also the largest level of equity, to give you an example. But despite this fact, overall, when you run the model, the result of the model, when you consider the original and the synthesized with rules, are pretty good. On the right side of the slide, there is the situation of across member states. And you can see that it's quite different. The main reason is because we didn't put any constraint on the sample to keep the same banks belonging to a single country within the same country. So the country has spread, but this is because, I mean, that's something that we wanted to do. So we didn't want to to impose any kind of rules on the place of origin of the banks. So this is a first attempt from our side to give an assessment of the quality of the synthesization. And I mean, to conclude, it seems that, I mean, there is a very good, there are very good results in terms of the overall distribution, especially when the accounting rules are imposed. Some features that are present in the synthesized data provides a good level of anonymization, so the privacy. Still, I mean, there is a need to find a very good, better estimator to assess the level of privacy. And at the end, when you use synthesized data, still you get very close result to the ones that you get when you use the original data. So the desynthesization is a way to provide the scientific community a large number of data sets where they can train their model and assess the results without having the problem of disseminate private information, sensitive information. With this one, I conclude. Sorry for the appearing of different windows on the screen.
We don't see what's written on it, so.
Okay, good.
Yes,
But I mean,
we don't see
nothing.
anything. Andrea.
Okay, yeah.
It was perfectly, we didn't see anything. Thank you so much. I wanted to ask, we'll pass the microphone so you will hear. Do you have any question? Yes, I will go around.
Thank you very much. So Massimo Caccia, Università dell'Insubria and Random Power, which is a spin-off company. So thank you for your presentation. I actually have a couple of questions. So the first one is trivially simple. So you possibly, I think both. So this is notably to Andrea. So you know the NIST was identifying 3 champions for synthesizing data. And the analysis they performed was actually very, very tough. So the first question is, how is your method standing against the NIST options, or maybe you're using one of the NIST options? The second one is more on the applicability to financial data. Because if you're talking about banks, the majority of the analysts might be interested in the outliers. And the outliers are actually a very, very limited number. So if I'm looking at Banco de Santander, Intesa San Paolo, and Unicredit, they are a handful. So if you destroy the information and mix them up, then you don't get anything useful. If you try to preserve all of the correlation beside and beyond the bivariate, then it's easy to see who is who. So this is why, for me, as an analyst, I would say, if I'm interested in the bulk of the statistical or the sample, then it's fine. If I'm interested in the outlier, I'm gone.
Okay, so very, very good, Andrea. I leave it to
Yes.
you. I just wanted to say that after Andrea, so after the European Commission, I'm coming, there will be also two banks, so two financial institutions, the Central Bank of Italy and Consob presented. So in some way we will answer you. Andrea, I collect more questions. Okay?
Okay, good.
So
Go
like
ahead, go ahead.
Thank you. Hello, Stephen Engberg from Denmark. We're working with trustworthy identity and data. I have two questions for you. The first thing is that I'm pretty much concerned that we talk about these pseudo-anonymizations as if it's solving the problem. You can't get more knowledge out of the data that you already created in the combined data set, and thereby the privacy problem was already created. Why are we trying to claim that this solves the problem? That's the first question. The second question is, it seems to me that the synthesization of data is missing the alternative, which is coming up in the EU digital wallet, where you distribute the control to the citizens so that they can share anonymous data for the further process. It's more complex, it's distributed, but actually able to solve the process instead of this approach that would actually create more of the problem.
Okay. Thank you so much. Any other questions? No. Andrea, just to tell you, we are in the worst situation. We are we love synthetic data, but we are in the middle of cryptography. So we are the enemy for them in some way. So please answer. Do you want? Can you? Some are very connected. So the floor is yours now.
Okay, the first thing that I want to show myself instead of the. So the real point is that, the level of anonymization. I can answer to both in the same way, I guess. You're right. People are interested in the outlier. For the outlier, I guess synthetic data are not as good because, for the outlier, it's a completely different story. So the main point is that this kind of solution for synthetic data should be thought as a new way to provide information which are on average, because that's the main point. Meaning on average in the bulk of the distribution, whatever, that should be good enough to train, to understand, because as Ali said at the beginning, one of the ideas is to provide information to innovative firms to see if what they are doing is correct or not. So having data which are more or less similar to the data that are available in a real situation. But yes, of course, if you want to keep the structure of the outliers, that's the anonymization goes away. I agree. So for the second part of the second question, I'm not sure if I get completely the question right, but still, in terms of you have to think about this process of synthesization as, it was, the slide that I show with a lot of word. So it's a way that people can now, in the world of big data, be able to, keep training their model, basically. That's the reason why we are after that. But I agree that, of course, as scientists, as researchers, I mean, we look for the outlier, but the outlier are there, as you said. I mean, there are handful, so there is no need. I mean, of course, if I provide synthetic data with the banks that has the largest value of TA, of total asset, the largest equity, the largest risk, I mean, we are in Italy, we know what we are talking about. Maybe you have a doubt about 2 banks, but more or less we know. But that's the point of the synthesization. And the slide that I show, where you mix the level of capital, the level of risk, and the level of the size, of course, I mean, it destroys this outlier in some sense, but keeps anonymization on the safe side. And still, when you do a modeling, still the results are pretty good.
Okay, so Andrea, I think the conversation will be kept because I have to, so as always, I have to move because we are late a little bit. But the conversation will be carry on because we are similar, all on the same line. Please, so if you want to, I hope that you can say, Alice, Andrea, thank you so much. And okay, so you can see me. Hello.
Yeah, we can see you.
Okay, very good. So we carry on now with Rosaria. Okay, we have everything. Yes. So the idea is today to see first the presentation from the Commission, then we will have an overview, and then we will have 2 case studies, one from Bank of Italy and the other from Consob.
Right, thank you so much, Francesca. Thank you, everybody, for being here this morning. What she didn't say is that you're going to hear from the Commission first and then from a philosopher second. So it's going to be a little bit of a bumpy road. Because I didn't know whether the talk would be in English or Italian, I did half and half. So there might be some moments when you recognize your native language. The key part of this talk today is to show that synthetic data are a double-edged sword. So something that is quite useful for some purposes, but this good potential comes with some important challenges, which are ethical, which are legal, which we need to solve if we want to go and harness this potential info. We'll do it in 3 steps. The first one will be see what synthetic data are in a quite generic way. I mean, Alice before gave a definition, I'm going to give another one, but it's to give you an overview of what these data are, what they are useful for. And then focus a bit more in depth on how they are generated, because this is where all the challenges and the potential stem from. And then I'll conclude with a set of recommendations, 3, not too many, to see how we can mitigate the risks and harness the potential. So, synthetic data. It's a growing market, and usually this is an indication of how things are becoming important when you see something like this. A market which was evaluated $288 million US last year, and is estimated to grow up to $2,339 million in less than 7 years. And the compound annual growth rate is about 31% per 1. So we're seeing something which is expanding. And if we look at kind of how the synthetic data are used per sector, you could tell from the list on the right that there is virtually no sector which is not thinking or using synthetic data. Some sectors more, banking and financing, but also healthcare, automotives. And this is important because it tells us that synthetic data are going to be an important piece of technology for the future. And this is a word I want to stress. We talk about data, but when we talk about synthetic data, we are talking about a technological artifact. And this is an important distinction to keep in mind, because data usually are something that is in nature and we measure. We collect data as data that are out there, and then we collect them, we analyze them, we structure in a data set. These data are a product of technology, and this is the key through which I want to look at this phenomenon today, and the key for also the challenges that hopefully will become evident in a few minutes' time. So what is the potential of synthetic data? One aspect has been mentioned a few minutes ago, it's privacy. Synthetic data allow us to do research, to investigate, to train model and use models on data which mirrors data which are privacy problematic or privacy risky, healthcare, financing, It's a set of areas where we won't be able to do as many things because there are huge privacy concerns, severe privacy concerns, because synthetic data are just a mirroring or reproductions of patterns occurring in those data. They help us to work out that kind of information without infringing or putting at risk the privacy of the data subjects. They're also quite useful to fill the gaps in a data set. If you have a data set which doesn't represent some minorities or has some gap, you can use synthetic data to fill those gaps. And you could also use synthetic data to mitigate bias, to correct bias, because you can balance the so-called information in the data set. They are also important for data availability. If you think about the use of data in the context of not only healthcare, I would say, but simulation for environmental disasters. Sometimes we don't have data in those contexts, and we could create data to help AI understand better those phenomena. So we can also address the issue of data scanty or scantiness. You can use data to train AI models, which is always seems to be doing these days, is training AI models, because you can provide data when you don't have them. And also for simulation and benchmarking. Smart cities is all about creating simulations and then implementing new infrastructures. When we don't have those data, we can use synthetic data to create such information. So it's a quite impressive potential there. For each of these categories, we have important challenges to consider. So it is true that you can protect privacy. It is also true that if your algorithms are not good differential privacy, those data can easily be re-identified. It is true that if you're using or focusing on outliers, privacy goes out of the windows, because outliers are outliers for a reason. So they stand out, so there is no way we can mask them up. So it's not necessarily synthetic data help with privacy. They might actually pose increasing issues if you don't produce them well, if the process to which you produce them is not solid and robust enough. If you don't do well your homework, if you don't produce them well, synthetic data will enhance bias because they mirror an original unorganic data set. And if you haven't done the work correctly, and in that original database data set there is a bias, well, that bias will carry through the synthetic data as well. There is an issue of transparency and accountability. And this is because the data are going to be produced through processes that at times are not transparent. And this is problematic because if the data then leads to adverse circumstances, healthcare, somebody's damaged, automotive, the car crashes, the next crisis in the context of banking, accountability is problematic to assess. So synthetic data creates or enhances very well-known risks for whoever works on AI, for example. There is an issue on accuracy and reliability. I'm going to come back to this one later on, but if the synthetic data are not structured well, they are not produced correctly to mirror correctly the phenomenon we're focusing on, then they may lead the AI model who will use them to make decisions to unreliable or misleading outcome. And then there is misuse. I'm sure we've all heard about fake information, deep fake. Well, this is all done with synthetic data, so this is a tool that lends itself to very malicious uses, which are very problematic, as we have witnessed, especially for democratic countries. So what are synthetic data before we move forward, understanding where all this potential and risks come from? The definition given by the Commission is quite correct. This is a more philosophically oriented definition because it stresses two elements. That a synthetic data is a data which is not directly determined through the measurement with an organic or a physics system. So it's something that is not directly related to a physical observation and is created through an algorithm. And this last element is crucial for what we're going to tell you in a moment. Because the focus is on how we generate synthetic data. This is kind of end of the story. I'm going to delve into this in a moment. But what you see is that there are two methods. There is a standard method, very much statistics, and then there is AI, particularly deep learning, where we use neural networks to create data. And this is done in two ways, using variational autoregressive encoders or generative adversarial networks. I'm going to delve into this in a moment. You create data for two purposes. Either you want to augment your original data set, if you have gaps, if you have spots in it, or you want to use a fully synthetic data set for your own research when you don't have the data, or, for example, when you want to protect privacy. The standard method, I'm sure that you are much more knowledgeable about me when it comes to statistics, but I want to give you an overview anyway. So the standard method is about trying to replicate some characteristics of the original data set, we'll call it the organic data set, by using either random or random sampling to balance out the original data set. The second technique or method, the deep learning, is about using neural networks to create new data sets which are completely new, so they're not just a hybrid data set. As I said, there are two methods, VAEs and GANs. Can I just do something very pedagogical, and by show of hands, how many of you know about these models? Okay, so it's okay if I spend 5 seconds to confuse you about both of them. So this is a variational autoregressive encoder, and this is an architecture. This is how a neural network, an AI system, works when it's creating synthetic data. You have an input, which is a data set that it's already simplified with respect to the multidimensional data set, the organic one. We take this data set and we give it to the encoder, and the encoder produces what is called a latent space. What it does is matching the variables within the data set to probabilities. Then we take this new set and we put it to the decoder, which all it tries to do is, given the probability, create new data that mirrors those probabilities. Very simple, right? So, and then it creates a new data set which is completely synthetic, and all it does is mimic the probability on the basis of the probability to which related the variables in the original data set. The second type of production, the GANs, generative adversarial networks, which is a very popular type of AI, of neural networks, has two agents, G and D, the generator and the decoder. What we take is, we take a data set and we introduce some noise into it. We give it to the generator. The generator mixes up and creates a noisy data set. We take this data set, we compound it with the same data set without noise, so the true data set, so to speak. And then the decoder has to guess what is what. What are the noisy data, what are the generated data, the original data, what are the fake data, or the synthetic data. And things, say the process ends when the generator and the generator keeps creating data, and the decoder cannot really distinguish anymore the generated and the original data. This is a very effective way of producing synthetic data. There is a quite well-known issue here, which is called model collapse. Because this is trained on the basis of game theory, and these two agents, G and D, are playing against each other, each one tries to maximize its own functionality, minimizing the one of the adversarial one. So what happens is that G understands quite early what are the data that D is not good at recognize, and keeps creating those similar data. So at the end, the model is not able to, or is not trained on a variability which is sufficient for it to create a very robust data set, a synthetic data set. Why am I telling you these things? Why is a philosopher talking about AI? It's a question that I often ask myself in my life. But because what I'm telling you is that synthetic data are produced through AI to feed AI. So this whole first part, it's about AI producing an artifact, which happens to be data, which we then to give to other AI systems to make decisions. So synthetic data is really AI for AI. It's a kind of a self-sufficient, also self-sustained circle. Why is it problematic? Well, because when it comes to AI, when we think about the ethical, the governance, the potentials and the risk I was mentioning before, there are very well-known risks that we have to address. And when it comes to synthetic data, these risks become exponential because they characterize the artifact, they characterize the artifact that we feed to another system. And so if there are ethical issues at the beginning, these issues will percolate and possibly be enhanced by the end of the process. What are these issues? I've already mentioned, you might remember the slide with the red dots, but when it comes to AI, there are some ethical challenges which are very well known, enabling human wrongdoing. I've told you about bias, we all know about bias. You might remember many years ago when the debate about bias started, about Google Images classifying as chimpanzee the picture of some black people in America. It's a bias. reducing human control. When AI systems are not transparent, when AI systems are black boxes, we are not able to understand, given an input, how the output is determined. And that means that if we don't like the output, we cannot really understand how it was determined, so we cannot challenge it. But also AI technologies in general are not really predictable. There is a certain degree of uncertainty with which we can predict the outcome of an AI systems. And if it's not predictable, we don't really control it. Removing human responsibility is very hard to ascribe the moral responsibilities for the actions of an AI system for two reasons. A, is not predictable, so it might be that an outcome is not really what we intended, and if there is no intentionality, it's very hard to ascribe responsibility. But B, the process is also very distributed, so it's very hard to understand who did what at what stage of the process to determine the outcome that we are considering now. And then there is devaluing human skills. If we start creating synthetic data, we might lose skills in terms of data collection, data labeling, and so on and so forth. And then eroding human self-determination, which is not really a challenge in our case, but is when we use AI to make decisions over and over. And then we empower this agent, not a tool, but an agent, to interact between us and the environment, giving us small suggestions about whatever we do every day. At this point, generally speaking, this reduces our ability to make choices. And then there is a whole issue of security. Now, these are problems that concern AI. Some of these problems are more pressing, more relevant when we think about synthetic data. Enabling human wrongdoing, if we don't create the dataset, the synthetic dataset, in a solid way, and we just mirror the original dataset, and the original dataset was faulty because he had bias, because he was not complete, that mistake is going to perpetrate, and because it's going to be more impactful eventually. We don't have so much human control because we're talking about neural networks, adversarial networks, which really lack a lot of transparency, which sometimes really are not predictable. So we are delegating the process of creating data, which we then use to make important decisions, to a technology which is not completely under our control and not fully transparent. As I said, because of this, we also are removing human responsibility. It's very hard to understand what goes wrong, but also who did something wrong. And then we have issues of security, which are, in my book, ethical issues, because when security is undermined, then the ethical values and the rights we want to protect, for example, privacy, well, they also go out of the window. So I'm going to delve on some of these aspects in the next 10, 15 minutes. 10. There are three sets of problems that concern the use of synthetic data when we think about them in terms of ethics or governance. The first one has been mentioned before. It's the need to define a set of trade-off. Now, usually so far, these trade-offs have been defined by trial and error. You try, if it works, otherwise you go back and you set the variables in a different way. But these trade-offs are very important because from this trade-off depends the quality of the synthetic data, and so the quality of the eventual decisions that the AI will make when we use this data to feed them to an AI system. The first trade-off is between the accuracy and the variability. A synthetic dataset needs to be accurate. It needs to be able to mirror not so much the original dataset, but the nuances of the phenomenon we want to measure. But also there has to be some kind of variability, because if there is no variability, well, for example, we go back to the identification of the data points. If there is high variability, however, so if in the dataset there are a lot of differences, there is also a chance that that dataset will have a lot of noise, and so there will be very low utility. At the same time, if the model is very accurate, then we generate a phenomenon which is called overfitting, which is when your AI system is able to cope only with a very specific situation, which is the one included in the training set, and not with situations in the environment which are a little bit different. The second trade-off is also very important, and is the trade-off between privacy and fidelity. When the dataset protects a lot, the synthetic data protects the privacy at a very high level, meaning that it's quite impossible to re-identify the original data points. Well, usually these data, they carry or they enable us to extract very little information. So they are not really useful. But when privacy is very low and fidelity is very high, so they mirror a lot the original data set, and so they carry on a lot of information, Also in this case, utility is quite low because we're not protecting privacy anymore. So we need to find the sweet spot between these two variables where we maximize utility and so fidelity with respect to versus privacy. And then the last trade-off, which is one which is not often mentioned, but is a crucial one. Producing synthetic data of quality, so that are usable, that protect privacy, that are scalable, is an energy costly process. It costs a lot of energy to produce data because you have to employ a lot of AI and it consumes a lot of CO2. So there is an issue of sustainability versus quality of those data. It means that as, I don't know, research institutions, as organizations, as companies, we have to understand how much is worth in terms of environmental cost to invest in synthetic data, given that they will have an impact on the environment itself. And so exactly, synthetic data which are of good quality, they are not really sustainable, and vice versa. And then the point of security, which is the key element to consider here. Artificial intelligence, which we produce to create data, and then which we use to elaborate those data to make some decisions, so extract information. So remember, AI is at the beginning and at the end of this process. It's a very vulnerable technology. Vulnerable to a different level, fragile to a different level than previous technologies, the digital technologies we have considered. There are three categories of attacks to artificial intelligence: data poisoning, tampering with categorization models, and backdoors. I won't delve into them, but basically data poisoning is when you give the model some data which are not correct to make the model act in a different way. Categorization model is when you change a little bit some ways in which the model understands the data to make it behave in a different way. And backdoor is when you add a little bit of a weird instruction into the neural network, so that when the network or the AI agents see that specific input, it will behave in a different way. You might got it. These new types of attack on AI are not attack meant to destroy the systems or to extract data. These are attacks that are run to change the behavior of the AI systems, to control the system that we are attacking. You might understand why this is important, because we are creating synthetic data with AI systems. If we get control of those neural networks that I showed you before, by one of these attacks, we can create poison data, which we can then further feed to other systems and make those systems behave the way we want. This is not sci-fi. I'm sure you have all heard about generative models and how it's easy to do exactly these things with generative models by using natural language. So if you just prompt a phrase into a chat similar to ChatGPT, like, give me the recipe of mango pudding, by writing mango pudding, you ask the model to jailbreak all of the guidelines and the restrictions that it has and to behave in a completely different way. So we are witnessing something which has important, severe security implications. And one other element about these attacks is that these are deceptive. It's very hard to identify these sorts of attacks, the one I mentioned before, because in neural networks they are not transparent, but also there is no source code. So if there is a trigger, for example, if there is a source of mistake that allows the system to behave differently than what we expect, but accordingly to what the attacker wants, it will be quite difficult, almost impossible, to understand where that attack originates and why the system is behaving in a different way. And this is because AI systems are, technically speaking, not robust technologies. They are susceptible to very minor changes into the environment, to the level that is very, technically speaking, we will say that is computationally intractable. The idea of understanding all sorts of possible interaction with an AI systems that might lead it to behave differently from what we wanted. So when we think about synthetic data in this context, they become the new Trojan. We are creating an artifact using AI, knowing that AI technologies are vulnerable, are fragile, and can be easily manipulated. We created an artifact that can be poisoned, and we're using this artifact to feed it, to give it to other AI models to make important decisions which concern healthcare, which concern finance and banking, which concern a lot of all the other industries I showed you at the beginning of this session. What's the answer? Should we throw synthetic data out of the way? Well, no, because these issues that we see today with synthetic data, we've seen for the past 10 years with any other outcome of an AI system. And this is the good news, because it means that we have a set of lessons we can learn from the way we manage the AI systems this far to mitigate these risks and leverage the potential, the good potential of synthetic data, because there is a good potential of synthetic data to be able to understand corners of the world or corners of our respective environments which we cannot investigate due to privacy and security concerns, even if of another kind. So what are the recommendations or the way we can go away and address these risks? These are three sorts. The first one is privacy is an issue. We can mitigate the issue if we do adversarial testing for privacy. Given a synthetic data that is used to protect privacy, we can start trying to do adversarial tests like the one done by generative adversarial networks to understand where the problems are and mitigate them into the data set. We should understand that those thresholds, those trade-offs that I showed you before, it's problematic to assess them via a trial and error process, because in those thresholds there is a lot of risk and potential to protect privacy, but also to create information which is of high or low quality depending on where we set the threshold. And there is also an important risk for the environment included in there. So there should be a strategy, allow me for the one Latin phrase, ex ante, at the beginning of the process to understand what kind of data we need, what's the optimal quality, and where we should optimize the process. And the last point is, we now heard, because of the AI Act, perhaps most of us have heard about the certification process, certification or auditing of AI systems. There is a way we can run auditing for environmental cost and ethical cost of synthetic data, and we should start doing it now. And I want to delve on this, not too much, but just to give you a sense, because there are processes, there are protocols for ethics and environmental based auditings, or EBAs, which is a structured process where whatever entity that is developing data tries to assess how is this process consistent with norms, principles, to make sure that there is a consistency with the value we want to protect. And we also define a governance mechanism so that we can influence the way an AI system is used to produce synthetic data is designed, developed, and so shape the result of the actual, of the end product, so that we avoid the risks I showed you at the very beginning of this session. The last point, EBAs is not a process that we do once. We should understand that whenever we use AI, auditing, and this has already become, it's not anymore the same use after the AI Act, but it's a process, and it's a process of refinement. So if you're using synthetic data in your organization and you want to avoid all the risks I mentioned before, the point is to keep an eye on those, on each step of the process through which we produce and use those data to identify where the problems emerge, when we are behaving inconsistently with the values and regulations of our societies, and intervene properly. And with this, I'll thank you, because I think I'm running out of time.
I think it was, the idea was to create a session with really a dialogue, a continuous dialogue, since we have two authorities. Yes, the same people, please, I would like to ask other people to ask questions. Do we have any other people? No? If not, I have to ask very short, because I have 1 minute now. Very, very short.
Yeah, very short. So I can tell you we could be discussing for hours, but I have to keep it short. I have to, yeah, we can continue. So two very short questions. So the first one, I'm not sure I agree with the definition given by the Commission, because about synthetic data, because the starting point are always the outcome of measurements. I'm a physicist, so for me measurements are the essence. And then the second point is, if you want to compare the two approaches that you have, that is to say something like differential privacy against synthetic data. So again, for the sake of time, we don't go through advantages and disadvantages. So I ask a direct question, which way would you go?
Okay, I go short, my darling.
Yeah, hi. Same question as before. It seems to me that synthetic data is a question of a methodology creating the problems without going back to asking the question, are we actually choosing the right methodology? Why are we not trying to create anonymous data at source And when that is not possible, decentralize the model to the level where the control should be. So if you do personal medicine, do it decentralized between the patient and the doctor instead of trying to centralize the process. My question is basically, are we actually trying to solve a problem with a methodology that is worsening the problem?
Perfect. Any other person? No? Fortunately, you are two here, because if not, there will be no questions. I was ready to give you the... Okay.
I got out too easily. All right, so I agree with you. In fact, in my definition, I say that these are data which are not directly the result of a measurement. That doesn't mean that they're not related to measurement. And in my words are important, so I agree with you. In terms of the methodology, I don't think there is a one methodology that fits it all. It depends on the purposes and depends on the risk appetite you have. If you need something that is quick, for example, then perhaps AI might be better than others if you are not too much concerned about some risks. So I wouldn't give a definitive answer. To your point, AI is bringing a lot of problems there, for sure. I'm not sure in terms of methodology in creating data. I think that's what you were mentioning, no? Why didn't you say that? Yeah, so let me rephrase it. Yeah. Let me rephrase it. It's unrealistic to think that we can create the amount of data we have these days from scratch in a completely privacy-enhancing or preserving way. So yes, from tomorrow onwards, we can start that kind of collection and creation, and we could create the different methods. But if we want to capitalize or harvest the data that we have today, which is already there, then we have to start thinking about ways in which we can mitigate the risks. Some of those data, for example, in genomics, can be used to understand rare disease. What do? We put them under in a safe, and we start recollecting them and take 10, 15 years to get the same point, and it seems that it's an unfair balance to me. But yes, there should be and space and room for new methodologies going forward. But my sense is we should also start to capitalize on what we have now. Thank you.
Does it work? No. Yes, I want to keep the time so you can have the coffee in time, and also we can carry on the discussion. So that was my idea. So now, one after the other, you will see two authorities. So first of all, Bank of Italy and then Consob. And again, it is a strange combination, because you will see, after a philosopher, economist. So, okay, I leave the floor to both of you. It's a difficult task to convince this.
Yeah, I see.
Okay. Let's try.
So, okay, thank you everyone. So I'm from the Bank of Italy, which is an authority, and my name is Marco Benedetti, and I thank Professor Taddeo for the excellent introduction. And I see that the two major points here are we creating with this methodology a problem that is worse than the solution? And then there are certain technical issues that have been raised about maybe the quality of what we are generating. At Bank of Italy, we don't really have a research line or direction on synthetic data. But at one point, we realized we are using a lot of synthetic data, and in different modalities of different forms, structured, unstructured. So in this talk, there will be no big ideas. Just a short list of real use cases where synthetic data are being used. You may recognize problems in the way we use or in the way we synthesize this data, and that's perfectly fine. We're just offering you our experience with this kind of data. And I leave the floor to my colleague Andrea, and he will be speaking about this. Thank you.
Thank you, Marco, for the introduction, and thank you, everybody, for being here. So, I'm Andrea Coletta from Bank of Italy, and as Marco mentioned, I'm going to discuss some use cases, some applications, challenges, and opportunities we found in synthetic data at Bank of Italy. And we decided to split this presentation in these three major points. Hopefully, you like it. Let's start with cybersecurity and synthetic data, and one touch point about the challenges synthetic data is posing especially the financial institutions. And I'm going to start with a video from our ex-governor, Ignazio Visco.
Good morning, everyone. And thank you for giving our applied research team the opportunity to present some of our AI projects. There are a lot of risks with AI, as you all know, but there are opportunities too, meant to be harvested. When I was in intelligence, I always had fun with AI for half an hour a day. Sometimes, I've believed as many as 6 impossible AI things before breakfast. So, I'm really passionate about this topic.
So, as you may have understood, this is clearly a deepfake video, and this is one of the main challenges we have right now with synthetic data, as also Maria Rosaria introduced before. So this is a real problem, especially if you think even right now, it's not just video, it's not just images, even text with these large language models. And so, especially in the financial domain, it's extremely important to understand what is real and what is fake. Fake news can really create serious problems, can create crashes in the markets, and whatsoever. So in Bank of Italy, we actually designed a system to understand, to recognize a deepfake video. This is a demo from our system, where basically is on the left side you have the deepfake video, on the right you have the real video, and basically our system developed by Oliver Giudice is able to detect some patterns in the video that has been introduced by the convolutional layers used in the neural networks that usually create this kind of video. These micro patterns are invisible for humans, but another machine can easily detect them. So we are able to distinguish what is real and what is fake. So this was one of the challenges that I think nowadays we have to keep in mind when we are talking about generative models and synthetic data. And you can find more information on our website on the right side. So going forward, I want to discuss, I think privacy is a very interesting topic for this conference. So I want to discuss about a system that we developed in Bank of Italy called Smart Anonymizer. Let's start with first the application, the problem. So in the bank system, you usually have a lot of privacy confidential data. I think after healthcare, maybe the financial domain is one of the most confidentiality. And this kind of data usually, several institutions would like to access this data to do their analysis, train their algorithms. Even public university, public institutions need to access this data. And of course, we need a system able to release this data without any privacy concern. So what we develop here is a framework called VADAS-SA, that is a reasoning-based framework based on Vadalog, that is this reasoning language that is able to release data removing all the privacy-sensitive information. And why I'm talking about that is that when you actually release the data, you are releasing a synthetic copy, if you want, of the original data set. And this is just an example with this data set, where you have basically companies with some identifier and some attributes. And our system is using, you can use basically any privacy metric. In this example, I'm using, for simplicity, the K anonymity with K equal to 2. And it's easy to understand that the first two rows in our dataset are not respecting this privacy metric because they are unique. And so they are exposing some entities if we release this dataset as it is. So our framework is taking some expert knowledge, some metadata to create some logical rules and the original data to basically create a synthetic version. What is this synthetic version? Basically, you have, of course, you remove completely, you replace with null value some direct identifier that you cannot, of course, release. But most important, what we did is to, this framework what does is to replace some attributes by using generalization or other techniques. So for example, here, Turin and Milan were exposing two entities. Our framework is able to reasoning about that and basically change the area with a generalization from the city's name to the region in Italy. And so now you don't have any more the k equal to 2 anonymity. So we are respecting the k equal to 2 anonymity. And this is a work done by Luigi Bellomarini, Livia Blasi, and Rosario Laurendi from our team. Oops. Sorry. Okay, sorry. Okay, so moving to another application. Again, this is an application where we actually design some synthetic data to enhance the development cybersecurity tool. It's called a Riot. So what is Riot? Riot is an AI tool that is made to support a role-based access control maintenance. So in large companies where you have thousands of users that want to access critical resources, usually what you can use is a role-based access control approach, where you define user, roles, and so you associate user to roles and roles to permissions. And given that, you have basically the final metrics on the right, where that defines what user can access. The problem, this is pretty straightforward. I think it's done in most of the companies. The problem is that when we have to update this kind of tools, it's not that easy. So for example, in this video, let's say that we want to give new permissions, but we don't want to change. So we are changing here Pop, Jones, and Williams with some exceptions. So this tool is able to do an optimization approach, trying to move from the current access policy to a new one, trying to optimize the simplicity of the new policy and how much changes we have to make in order to have the new policy. And this is, again, it's computing right now, the new policy, and we will get the new users and the new roles that we need to respect the permissions that we want. And so what you can see, you have now a generated role number 3 that is basically giving access to a new kind of resources and respecting the permission we want at the beginning. And also this tool gives you the optimization plan. So which are the steps you have to take in order to implement the new policy. So why I'm talking all about that is this is giving you the context of what we did, the application. But when you design a system, you don't want that your system works just in the current situation of your company. You want to test your system in a plenty of different scenarios, from the smallest company to the largest company you may expect. Because maybe we design this system in Bank of Italy, but we may introduce this in the European Bank. So what we did here is to create a set of synthetic benchmarks. And we create around 125 gigabyte of synthetic maintenance task. And we use this task to help the development and the test of this Riot system. So these synthetic benchmarks start from these 4 datasets. The first one we create from scratch is representing a small company, and the other 3 we take from the literature. And what we did here is to compute the initial role-based access control policy, and then we introduce one exception. So we want one new permission for some users. And creating these new permissions create actually the maintenance task. And this has been published in a research report you can find in our website. The second set of synthetic data is basically same data set, but now we use single and multiple updates with both new permissions, or we want to delete some permissions. And all these benchmarks, again, you can find on our website. We release this kind of synthetic data, but most important, these benchmarks are now part of the official MaxSat library maintained by the University of Toronto. Okay, so this was more, these 3 projects we're trying to cover more about cybersecurity, privacy applications that we had in Bank of Italy. Now I want to talk another real important area for that where synthetic data can really make the difference is accelerating research, and this is a bit connected with the previous example. So when we create and when you use synthetic data, is also helping to develop new system where you don't have data, or where basically you need to do research but still you don't have the data to start the research. So it's trying to accelerate the development test of policy algorithms. So the first example is about the generation of stress economic scenario. So this is a document from the Fed, the central bank in America, in the US, where basically these are stress tests. So usually the central banks, what they do is to release a stress test. So they try to forecast different possible scenario for the future economic growth. And this document, for example, you can see that the Fed in 2022, they expect this baseline scenario of the US economic, like they expect the unemployment rate to go from 4% to 3%, or the inflation to go from 8% to around 2% at the end of this stress scenario. So this is very useful because it's given to banks and financial institutions to assess their performance and their stability. But the problem is that they usually release just this set of hypothetical conditions. But in an even more data-driven world, we cannot just use these conditions, we need the actual data. So what we did here is a system to create synthetic data starting from this kind of constraint, this kind of conditions. So in this example, the solid lines are the historical data for these 5 economic indicators. And what we did is to use these conditions to basically generate the baseline scenario, so as a kind of synthetic scenario for the future that now can be directly used by banks or financial institutions to test their strategies or algorithms. And as we mentioned before, it's extremely important that we keep in account the fidelity of the data, because we need useful synthetic data and all the other properties that you may find in the historical data, like the correlation, for example, between different economic indicators. And this is a work published in NeurIPS that is happening right now in New Orleans. And I also demo for this work that I want to show you. This is based on diffusion model that is a kind of generative model. And basically the idea is that you can provide the conditions as text, for example, but you can even draw a kind of future scenario you want to generate, and the model is going to generate a synthetic sample that has the trend and the statistical properties of the real data. And this gives you the flexibility to generate any kind of scenario you want to test. And you generate this kind of trend having all the statistical properties of the real data, so it gives you more confidence of what you are testing. And so, for example, here we can generate a downtrend market, for example. So this was an example in which synthetic data can actually be useful to improve economic research and the test and development strategies. So moving to another important point for our bank is the use of knowledge graph. So in the financial domain, usually you have different entities. So you have central banks, companies, owners of the companies, and you can think all these entities as a large connected graph. And that's why we have actually a great effort doing research on graph and knowledge graph that you can use to get some information on what is going on the financial domain. But when you develop algorithms and policy for knowledge graph, usually, especially in Bank of Italy, we have the Italian graph. Like this is an example of the one very small real knowledge graph from Italy. And yeah, it's huge, it has some very good properties, but the problem is that what if you need to implement your algorithm in the European community or even worldwide? So where synthetic data can be very helpful here is to create, starting from this small graph, similar graph in terms of properties, but with much greater number of nodes, number of edges. So you can test your strategy, your algorithm on a different kind of scenario. So again, this is a case where synthetic data can actually improve and accelerate your research. And there is not an easy way to do that without synthetic data, because having access to largest graph, they may not exist, or it may be very complex to do that. So the last point is how we can use synthetic data to get some real insights. And I want to talk about creating synthetic data using agent-based models. So what agent-based models are? I will start from this example. This is an example in which you can use an agent-based model to simulate the spread of COVID-19 in Tokyo. And the idea is that you basically are modeling the underlying system. So you're modeling the people and their interaction in a simulation. And by their interaction, by running the simulation, you can actually see how COVID may spread in Tokyo. And also you can get some useful information like the number of infected people, the number of people that have recovered. And so the idea here is that by modeling the underlying system, that sometimes you may know much better, you're able to get some micro value like the average number of infected people, the number of the percentage of people in the hospital, and so on. So this is, if you want, another way to generate synthetic data that is not deep learning, that is not standard statistical approaches. And why this is useful and very nice is because you can create actually different kind of simulation. This is an example of that we replicate a study from the literature where an agent-based simulation, where we create an agent-based simulation for the central bank digital currencies. So what you can do is to simulate the interaction of people, how people spend money, using physical cash and commercial bank money at the beginning, let's say for the first 200 days. Again, using the agent-based modeling. And then you can actually introduce in the simulation the use of digital currency. So what you have is that at this point, we introduce the digital cash. And so now you can create this kind of counterfactual scenario if you want. So this kind of synthetic scenario in which you may study what can happen if you introduce digital cash. So you have a big jump at the beginning where more agents in the simulation start using digital cash. And then you can see that more or less the use is more stable over the last 200 days of the simulation. So this is an example where synthetic data can give you an idea of what could happen. So a kind of counterfactual study or more real insights before you actually implement some kind of strategies. And you can find more information on our website on this project. Oh. Sorry. Okay, perfect. So last, I think everybody knows now about large language models. I think they are an example of synthetic text data. So I just want to say that in Bank of Italy, we are exploring how to use these models. How to use these models to generate policy brief. So basically, we are asking ChatGPT, for example, to write some documents for the bank and trying to understand if they keep the same style and if their content is correct enough to be used in a financial institution, where, again, it's very important to have only correct information, accurate information. So we find several advantages: fast generation, responsiveness. You can use to quick edit your text or to brainstorming as well. But so far, we also have some disadvantages that are extremely important to address in a financial domain, because we have superficiality from these models, and we actually need accurate and precise information. We need to have something that is more strong. And so this is something we are trying to address, and this, I think, is still a challenge for using large language model in the financial domain. So thank you very much.
They didn't approve before. So let's do like this. Since we have very few minutes, we do the presentation also of Consob, and then, because I don't want to stop you to have coffee, and then we do the questions together, because we are in a similar. Okay, I will be a very short. I'm presenting, so I will do the presentation very short. So in order to have the time for the colleague to have questions, are we agree? Yes. Yes. No. Okay. So fine. Grazie mille. Allora, aspetta che lascio questo qui. Okay. Yes. Different from Bank of Italy, in this case we were, so this is Consob, in reality it was just me that did this experiment, because I wanted to test if we were able to implement a pilot within Consob about synthetic data. So in reality it's because I have here the vice director of Consob. The fault is only mine, plus one of my students at UCL. So the idea was, are we able to whiten in the black swan? And that was the concept. Here is the concept that I will try to explain today. So one of the main problems in finance are exactly this problem of having rare event, really rare event, and this is the fundamental problem that we have also in Consob when we consider the data. We also wanted to study and use machine learning, so we wanted to combine two things. So at least I wanted to combine two things, looking at the extreme event, which are very important for us, and the use of machine learning. The problem of black swan, I give you here the fundamental definition given by Taleb in 2017. So extreme impact and rare event that are unpredictable, and usually the explanation is given retrospectively is very simplistic. And for us it's very important, because if we think of Lehman Brothers fault and so on, you have immediately, so here is when we talk about black swan. But we have also many other black swan. This is one. And then there are other examples of black swan. So for example, here is the study that is done in the United States about oil price and connection of macroeconomics variables. This is a fundamental study that's used continuously in order to evaluate the value of the economy when the economy enters into recession. Remember that when central bank as well, ministry decide that we enter into a recession, there are policies that impact immediately also the life of the citizen. The other point, real GDP with COVID-19, again, you see a black swan. And the other one is the war in Ukraine, and here is again in the United States and also in Europe, the business sentiment index, which is an index that gives us the information about how the industry in a country is working. And of course, when we are under 50, the value of 50, the economy is shrinking, and when we are over 50, the economy is expanding. So that is a fundamental, all the fundamental elements. The idea here, however, was another point. After the crisis of 2008, where it was again a black swan event, so it was not predicted by economists, immediately was introduced by the central bank a new stress test. And the introduction of the stress test, like they've shown Andrea, are just a single scenario, so scenario where the data have to be fit. And it's just created in order to evaluate the resilience of the banks, not only the central banks, any banks, to possible events like this, negative impacts. What happened, since we have this scenario, is the process of stress test is very static, the impact immediately is on the economy. And what happened, for example, in Europe, we had an immediate restriction of loan dedicated to infrastructure. So I did a study very specific for the UK, that after the crisis, the banks started to stop any kind of loan dedicated to major infrastructure, so large infrastructure like road, water, protection, and so on. Do not talk about social infrastructure like school and hospital and so on. And the impact, the link between stress test and so the requirement requested by the banks and the economy, it's also seen in other aspects, and particularly when we look at loan to small and middle enterprise. This study we did for the United States. So in United States, after the introduction of the new stress test, the reduction of loan dedicated to small and middle enterprise was evident and was very strong. So of course the answer will be, okay, let's change the stress test, but you know, economists are difficult to change and they like to create a scenario that works like this. So okay, the idea was, okay, let's check if by introducing another system, so introducing machine learning, it's possible to create a system that is more adaptable to the situation, is more flexible, and adapt particularly to the event when happened. So that was the initial idea. The other point was also to predict any kind of contagious event that after you remember the crisis of Lehman Brothers. So the contagious, in order to stop that, in order to predict any kind of possible event, very negative. Okay, so black swan in bank, usually we have, you see the available data are usually the green one, so the normal scenario, and then we have a small, a tail scenario, which is usually is a 5% of our data set. So the problem here, like Maria Rosaria was saying, is that we need to create a data set that is more balanced, because if not, the machine, the algorithm of machine learning will not learn, and will learn only on the normal scenario, and not on the single tail scenario. This kind of algorithm where we have to rebalance the data set I use very often, and I use, for example, in aviation, because in aviation we have a very few crashes. So the algorithm that run, for example, the automatic pilot will need to have some kind of data that imagine a lot of crashes and then can drive the airplane. Okay. So we use a very standard system, the more standard that we could, in order to avoid possible error that were available. The other things that we wanted to overcome was the situation of privacy, but I will not go there into because we have already discussed very much. Also this, okay, I just avoid some of the aspects. Okay, so so the objective here was we needed to evaluate the resilience of bank, so liquidity, present, future of the bank. We had a lot of information from the spreadsheet of the bank, and in particular we had the data from United States, so the Federal Deposit Insurance Corporations, these are the data from the bank side, and the Federal Reserve economic data from the macroeconomic data. The period was from 2001 to 2020, so we had quite a large data set that we had to consider. We wanted just to reproduce the stress test that the central bank required to do, and just that was our goal. And in order to do that, we needed to calculate what is called for the central bank capital adequacy ratio, which is the index that gives us the indication of the resilience of the bank in case of crisis. So that was the situation. Difficult aspect, first of all, because we have a tail, and the tails, as always, as all the people here can tell me, quite a lot of problems. So I had the tails, and I had to reproduce this tail in order to create a synthetic data. So that it was just the first point. But the other point that Maria Rosaria said was the preparation of the data. So we did the preparation of the data with we tried to be as careful as we could, and because that was the most difficult. As we know, as you trash in and trash out, that was the fundamental point. So we created, in order to introduce the data that we needed to do a synthetic data set, we needed to create a sample, and the sample was originated from the total sample, and then we started to decide how to extract the sample. So the sample was extracted through principal component analysis in order to identify across the 100 variables that we had in the spreadsheet of the banks, how we could extract the variable that we needed and the sample. So at the end, we were satisfied, but we did several runs in order to identify the sample for the training of the algorithm. So that was we thought that by using principal component analysis, we were able to verify that the sample didn't have any major error, and we also could verify again what we had. As you can see, we divide the banks in relation to the amount of assets that they had, and so there are 5 classes of banks. Now we enter in the specific of the synthetic data. In our case, we use again an adversarial generative network. We use that algorithm because first of all, okay, I was in some way I'm old enough that I knew this algorithm from where I studied. So it's a very old algorithm, very, very well known. So there are quite advanced system that we can check and verify and so on. I like it very much the fact that we have 2 neural networks that are training and learning from each other. because I'm an expert on game, we can also verify, so the game is not really completely no control. We can control the game. It's a zero-sum game, so the two networks works in adversarial way, but in some way we can control also their objective. There are no really adversarial. You can create a network in order to be really adversarial one with another, but also you can give additional things, and that was what we were doing, in order to not create the fact that one of the two networks, the discriminative one, start to understand what is the generative weakness, and say, okay, I know exactly. So we did this modification. So that was the additional and novelty, the novelty here of modification of the algorithm. So we have created a completely new algorithm that I think works a little bit better, but okay, it's always, this is just a first step. What we did also, our game was this: we take a sample, the sample that was created with synthetic data, and also the original sample. And we wanted to verify if by apply, so if we were reproducing something that was accurate in relation to the data that we had, the original data. Okay, I want to move fast so you have more time. Okay, so these are the results. You can see here the capital adequacy reaction. So that is the output that we needed to obtain. And in the two sides, you see all the different sample. And then you see the original data and the augmented data. The augmented data is a data that has the original plus the synthetic, so it's not total synthetic data. And as you can see, we perform, so what you see here are just some tests, but we perform much more, we did more tests, of course, but just to have an idea, so of course you see the R square, and then you see the root mean square error, the RMSE, and then the mean absolute error, just to have a measure of how to confront the two data sets, if they were working fine or not, in relation to the results, so the output that we needed to obtain, so CAR. And as you can see, the augmented data works relatively well, I would say well. And this is important because, again, as an authority or as a bank, I needed to see if the results works better than for who I have to work for. So, for example, like I said before, small and medium enterprise, if I have to do loans. So in some way, the system allows me to be more flexible, not more flexible. So there is no so strict limitation on liquidity for central bank by using an augmented data. So I have a major leeway to give a possibility to bank to give loans. Okay, so that was I think the fundamental results. So for me, it works well. I have to say the results, as you can see, they're not so bad, because remember that but you know, you are a mathematician, so you know exactly what they give you the answer. Sometimes not very well, so that is good. As Andrea said, we have the diversity, so everything almost satisfy us. But that was the first step. I wanted just to check the algorithm, if the modification of the algorithm was satisfying better the requirement that I had. What I want with an algorithm like this, we can do quite a lot of things. Of course, we can train data, we can do strategy testing, but of course, you've seen now, you can, for example, create a synthetic data to personalize the investment. So that is one of the possibility. Or these are more commercial application, and evaluate a risk. This is one of the other, and alpha generation. So these are all the and privacy anonymization. In some way, you saw all of that. I will stop just 1 second to the threat prediction and security testing, because we are here in a cyber. We were talking yesterday about cyber security, and again, this can be used as a training methods, particularly when we have black swan events. But exactly, that is one possibility. I think, no, I had something else. No, these were the application, sorry. These were the application, the institutional application I was thinking. So risk, so very much in line with what you do when we do cryptography, so threat, privacy, alpha generation, and risk assessment, with a node with a different problem that we have raised this morning. I'm looking at the time. 11 o'clock. I'm so good. So, okay. So, what we wanted to do in this exercise that we did in Consob was just to test. It was just a small test, and just to see if, particularly because in finance, black swan are very difficult for us, and in Consob one of the major problems are market abuse and market manipulation. Market manipulation is one of my most difficult things to detect, because they change continuously, and every time that we find one species, one other will be created. So this was the idea behind this experiment. I think the experiment in some way worked well. We did a modification of the algorithm that satisfy, at least for the first test. These are the first tests that we did. Our ideas and our objective. We will carry on the studies. We are not yet published, so you cannot find. So you can write to me. I can send you the test for now. I think I stop now. This is my emails, which will work until the end of the year, and then switch to my UCL email. And I wanted to, since we are in a perfect timing, satisfied 11:02, I wanted to leave again the floor to the colleague of Bank of Italy if there are any questions, also to me. If not, we can have coffee and networking at that point, and answer and ask questions as you prefer. I leave it to you, because I'm a democratic in this case. And after the timing, I'm starting to be. What do you want to do? We go to have a coffee? Do you have any question for colleagues? No. No, everyone wants a coffee. Yes. So let's have a coffee. Thank you so much. I really like it. Thank you.
scusa, ma Andrea non c'è? Andrea dovrebbe stare con te qui. Però vi volevo indicare che l'altro organizzatore. Lo vedi? Okay, it's time to start with the new session. Now there is a workshop. It's a CIFRIS Innovation, which is a workshop which will focus on different topics from here to here, if I understand. The focus this year is on digital currencies and the implication, crypto assets and the like. So it's organized jointly by Andrea Bracciali and Davide Carboni, and now I leave the floor to them.
Thank you, Massimiliano, for the introduction, and welcome everyone. And yes, as anticipated, this workshop is about, let's say, the topic is twofold. On a side is about the central bank digital currencies, which is a hot topic with a lot of debate between institutions and also advocates of privacy and so forth and so on. And the other topic, which is also, I think, very important, and that can be like a new, let's say, wave of applications in the next future, is about tokenization of financial and real estate assets and so forth and so on. So here I would introduce immediately the first speaker, which is Gianfranco Trovatore, head of Law Studies Office at Consob, adjunct professor Università of Catania and Naples, with the first speech is crypto assets value and investor protection. The floor is yours.
Thank you so much, Chairman, for this kind invitation, as I'm very pleased to participate in this first Congress of Cryptography, and which has been very interesting even for those people like me, which is not particularly skilled in, say, IT, maths. I'm a bit more skilled, or at least more experienced in financial regulation, and therefore I will intervene on this issue, and in particular, I will intervene on the relationship between crypto assets and investor protection. This is a collection of terms used when defining or classifying what is a token. As you can see, it's really a mass, directly deriving to a polka dot pattern like this. But even though the taxonomy in this field is particularly confusing, both Italian and EU regulation are clear and strong when it comes to the need of investor protection. This is the index of my intervention. I will very quickly describe the need of investor protection among jurisdictions and focusing in particular in the need of protection and several categories of crypto assets, such as cryptocurrencies, investment token, utility token, including NFTs. And then I will remark that even those crypto assets completely different, completely unrelated to finance, as for NFTs, representative of a contemporary artwork, say, the need of investor protection might be very, very relevant. In the Italian Constitution, first of all, there are two articles that directly refer to the so-called savings, and in recent decades, savings have strongly oriented towards financial market that has become the cornerstone of the economy in many developed countries. In EU, regulation has been recently adopted, and it has been mentioned yesterday by Generale Bianchi of Guardia di Finanza, a set of rules called MiCA, that gives power to competent authorities in order to ensure three general interests: investor protection itself, market integrity, and financial stability. The latter one is more connected to the competences of Banca d'Italia, while the first and the second are more connected to the competences of Consob. In the Italian law has been as well recently adopted also another set of rules, the so-called FinTech decree, and let's skip immediately to the decision adopted by the Italian courts in recent years, and in particular starting from 2020, the Italian Supreme Court, the Corte di Cassazione, has adopted pre-judgment, and more recently Tribunale di Milano has adopted a decision in May of this year, and all these decisions are focused on the possibility to include a specific kind of crypto asset in the scope of the investor protection rules, subject to a certain set of conditions which I'm going to describe as follows. Let's start from the need of protection and cryptocurrencies. Let me immediately clarify that cryptocurrencies are not financial instruments. This is a numerus clausus, as we say in Latin, and we cannot integrate freely this taxonomy. But cryptocurrencies could be financial products given the presence of three distinctive elements which have been outlined by Consob. The first is the investment of a certain amount of money. The second element is the expectation of a financial return. The third element is a risk directly connected with the capital invested. It's of course the subjective expectation, in other terms, the reason why the investment is made, is not of relevance to determine whether such assets qualify as a financial product. We should see very careful to the objective financial purpose of the transaction. The need of investor protection is particularly high for currencies. Among the others, the most popular is Bitcoin. Algorithmic cryptocurrencies are those not underlined by a specific stable currency or other asset, but whose value is tied to the fluctuation of supply and demand of the market. In the United States, the offering of cryptocurrency may lead to investor protection following the so-called Howey test, which has been outlined in the past, 1946, by the Supreme Court of the United States, and the so-called Howey test. Of course, it was not directly referred to the tokenization, but it's very useful also today. In the EU, many legal systems, including Italy, as I told before, lean towards protecting investors very assertively, and the entry into force in 2024 of MiCA will certainly give us an harmonized legal framework within the Eurozone. Let's go very rapidly to the investment token. Of course, the investment tokens are those more directly related to finance. And right this week, Consob implemented the FinTech decree by adopting a set of rules on the issuance and circulation of financial instruments on DLT. And this regulation laid down principles and criteria related to the maintenance of the list of DLT's operator. For those firms that want to tokenize their assets, and in particular assets related with share, bond, also relevant in the FinTech decree is the envisage of an experimental framework to assess the impact of this new technology and its so-called pilot regime. Let's go to the utility token, including NFTs. Utility tokens may be underlined by a good or a service different, of course, with respect to a stock or a bond. And also they could raise a need for investor protection as financial product according to the three elements which I mentioned before. And NFT among the utility tokens are those tokens unique and not fungible that in principle, according to MiCA, should not involve a need of investor protection due to their not interchangeable assets. Nonetheless, MiCA explicitly outlines that when assessing and classifying crypto assets, competent authorities should adopt a substance over form approach. So at the end, in order to summarize, it's all about value when talking about tokenization. And I would like so give you a rough example of the tiny boundaries between an investment and an NFT with reference to this case study. Did you believe that I have chosen the Polkadot pattern at the very beginning of my intervention on a randomly basis? Not at all. Because the Polkadot pattern is the core of this painting made by one of the most prominent contemporary artists in the world, Damien Hirst. And this is a screenshot of Christie's auction closed almost 1 year ago, when this painting was sold at around 12,000 euros. What does it have to do with tokenization, one could ask? Well, this is one of the 10 original artworks which correspond with 10 original NFTs. Collectors were given the choice to either keep the NFT or exchange it for the physical artwork like this. But this choice had serious consequences. Let's see what kind of consequences it had and the characteristics of this project. The relationship between this artwork collection and the financial sector is not my free assumption, and it is made clear by the content of the conversation between the artist, Damien Hirst, and Mark Carney, which is the former governor of Bank of England and of Bank of Canada. Please, can start the first clip.
But in the end, it's based on trust. Money's based on trust. It's trust that the gold's really there in those days. Now it's based on trust that the institution will make the right decisions. Money will keep its value. And at the heart of this is also a sense of trust in the underlying art. But there's what I find unique, well, there's lots that's unique about it, but once you add the NFT, then doesn't the purchaser have a choice to make?
The purchaser always has a choice, but I think what's exciting about this project is we're forcing people to make the choice.
Exactly.
Because it's not, you can't have both.
Yeah.
I mean, we thought long and hard about that. Because you can look at it and go, well, we're going to sell paintings and we're going to give free NFTs, or we'll sell NFTs and give free paintings. and then you can kind of do what you want and see what happens. But I think it got more exciting when we started thinking, no, it's like, I mean, for some reason, I don't know why, it's like the kind of art world really distrusts the crypto world, and the crypto world distrusts the art world, or the real world, if you like. And it's like, you know, there's a lot of people who are like totally into crypto, but then, are they really? I don't even know. But then to sort of...
Well, they're into it as it's going up. They tend to be more into it.
Yeah, exactly,
It's a little more...
Yeah, but also it challenges me, because the way I think, you know, like in terms of it as a project, I think everyone's going to go for the actual artworks, because obviously actual artworks are more important than crypto artworks. And then I think, no, that's me being like stuck in the mud.
Yeah.
I don't even know. So that's what's exciting, is I just don't know what people will do. I guess the question is, you know, which would you rather have? If you put this is the hard thing, if you put the value aside, which would you rather have, an NFT or a painting? And then the answer is you can't put the value aside.
Yeah.
So it's you know, the jury's out, so that's why it's an experiment, really.
Let's take a look to another clip, which shows some clues about,
you know, all these things, art, money, pieces of paper, or on, you know, things. Belief. Yeah, belief and trust. What if I made these and then treated it like money or something? And I thought, if I made more than 500, what if I made like 1,000 or 5,000? And then we looked at it and we realised that 5,000 wasn't... I mean, I can feel the confines of my beliefs. So for me, it's like, I mean, I shouldn't, as an artist, have a problem with, you know, it should be an equal problem to burn an NFT or to burn a piece of paper. But I have a much harder problem burning the paper than I do the NFTs, and that exposes something in me. 100% of the art's burnt and it's all NFTs, and I'm like, oh my God.
Well, in July 2021, we issued an offer to the public, 10,000 NFTs, each one representative of a slightly different painting. Each painting was numbered and named differently. The polka dots are handmade and look slightly different in many ways, color, size, and so on. Exactly 1 year after, in 2022, NFTs buyers opted in or out. The painting corresponding to the NFT opted in were destroyed in London during the meeting held in October 2022, which I have seen now. Also, the almost 5,000 NFTs corresponding to the claimed painting were destroyed. Well, in DLT, you can destroy effectively a token. More precisely, they have been segregated within an unreachable and hidden address of the DLT itself. If you are curious to know whether Damien Hirst, who reserved to himself a certain amount of items, kept the NFTs or the paintings, well, he declared that he was going to opt for keeping the NFT and therefore to destroy its own paintings. We can go towards conclusion, seeing what happened in this price chart. You see, from July 2021, the price of the NFTs still underlined by the physical artworks was very high. And in July 2022, well, slightly before the destroying of the paintings opted out, the price had a spike. But after that moment, the price dramatically dropped because the NFTs were any more underlined by the physical artwork. A few litigation, not necessarily related to the project of the currency, but to other projects, as shown in this slide, have already started. At the end, let me repeat that again, in the matter of crypto assets, each case must be assessed individually. And the offer and the trade of this token based on the artwork of Damien Hirst presumably don't fall into the scope of the rules aiming to protect investors. There is still a little amount of non-fungible elements in this case, but as I can see, and as you probably could see also, the boundaries of this case with respect to an investment are very, very tiny and fragile. Thank you for your attention.
Thank you. Unfortunately, Professor Trovatore has a very tight schedule, so he can stay with us any longer. So I would go immediately for the second speech. If you have any questions, you can send to us, to the moderators, and then we find a way to forward to Professor Trovatore. Thank you very much.
Thank you so much. Many apologize for
Thank you.
You're welcome.
Bye. Then, let's go immediately to the second. Sorry. So we have on the speech corner Vincenzo Vespri, Professor of Mathematics at University of Florence. That's correct. And the title of the contribution is What Consensus Mechanism Will Be Used for Central Bank Digital Currencies?
Thanks a lot for the invitation. This is a continuation of a work that I was starting to do with Andrea in a book edited by Zatti, and then we are essentially inverting, we are doing the permutation. So now there is Vespri Zatti and Andrea that is organizing. So next time I should be the organizer in order to conclude the circle. I am a mathematician, I like symmetries. Well, what was the question? The question was that in the previous paper we are realizing that essentially people are speaking of central bank digital currencies without considering the technological problems, in the sense that they are assuming that the central bank can do everything. They can do a financial digital infrastructure that will be absolutely expensive, as is taught in these papers, without considering that I think that the government don't want to spend so much money. Our idea was, in the continuation, to speak about what is the final aim of the central bank when they want to do the digital money. What kind of digital money they want to do? They want to repeat the experience of cryptocurrencies, or they want to make a digital infrastructure. Considering this means different choice of consensus mechanism, because there are consensus mechanisms that are very expensive, and other consensus mechanisms are not so expensive. What is clear is that central banks are absolutely interested to these central bank digital currencies. From some research paper, it resulted about 80% of central banks are thinking about this. Obviously, it's clear that even if I don't think that the final aim will be the cryptocurrencies, the central banks are looking at the technology that are developed in the blockchain technology. It's not clear if it will be blockchain technology, but it's very probable that if will be the central bank digital currencies, blockchain technology is the technology that more or less must be chosen for several reasons that already we have explored in the paper with Andrea, because it's clear that the technology that has the more advantage and more suitable for such kind of things. Well, I think that the first choice to do is permissioned or permissionless. The difference is big because even if there is a lot of progress in permissionless, in the sense there is not a central authority, still the permissioned has a lot of advantages in case of cost. Moreover, without central authority, there is what is called the Buterin trilemma, in the sense that it's difficult to get together scalability, security, and decentralization. Well, the anonymous blockchain is more complex and energy consuming than permissioned. But the cryptocurrencies does exist because they are anonymous, in the sense that if there is not this characteristic, the cryptocurrencies were burned by cyberpunk in California exactly to have a way that the government cannot track your movement of money. So if you want to have the central bank digital currencies as a competitor of cryptocurrencies, you should in some way to choose a permissionless, because permissioned in any case means that your money is tracked. This is, by the way, I think that to have the money tracked, to have a financial digital infrastructure will be a great thing, in the sense that means that something that for the moment is spread out, is given to the banks, the state, the government are choosing as critical infrastructure. This is something, so to block the payment of credit cards in this society means to destroy the society exactly like to block other things. So perhaps the government should have a control on that, more deep, to have the full control, because they have the control, but the full control. Well, the idea will be absolutely a great advantage for fiscal things, because for the citizen, for several things. The NFT that the previous talk was speaking about could be directly inserted in this critical digital infrastructure, but it means that you are tracked. It means that if a week ago I was buying for Christmas gift a book for children to my nephew, and is a week that I'm receiving ad about book for children. So it's something that you want to avoid. And it's clear that if you are using credit card, I was using a credit card in a bookstore, you cannot avoid to do this, because perhaps the bookstore was connected and you cannot do anything. So if I want to avoid this, you have a system that is permissionless, in the sense that I don't want to have ad of something that I don't like. In a certain sense, if you are working with a permissioned system, will be absolutely, I don't know, you can make a reliable, regulated than private companies, so it should be only advantages. You can pay tax, you can make smart contracts, so it would be what the cryptocurrencies are showing us is that the money must be evolved in a different way. The concept of financial exchange can evolve in a great way, and this can be done also in a permissioned system, in an efficient system, with the problem for the state to accept the cost and the security, because it's clear that became a problem of the government to assure the security of the system. If perhaps the only possibility is that to have two different central bank digital currencies. One that is permissioned, so everything can be tracked. Another one that is not not permissioned, where perhaps the only things that is tracked is who is receiving the money, not who is paying. So if I'm going in a bookstore, the bookstore says that they have sold the book, but it's not written, it's not tracked who is paying for the book. In this way, you are blocking a way to be tracked in order to defend my privacy. Well, if you are doing only this, well, you are covering a lot of needs. It costs slightly more, technologically speaking, so could be a cost like a credit card, about 1%, 2%, something like that. But this way is not covering all the need of central bank digital currencies, in the sense that there are some payments that people don't want to know that they are buying, and people don't want to say they are selling. For this is quite a problem, because the only answer are cash or cryptocurrencies for such kind of payments. Otherwise, one has to change, I was speaking, the combination with Zatti is a guy that is expert of legal things. So this is something that is going to the legal things, in the sense that if you are making everything anonymous, becomes a problem for the government to fight against illegal things, to go against payment of money laundering or something like that. So I think that already, if we have the central bank are thinking to do something permissioned, would be a great progress, in the sense that there is the idea of a financial infrastructure, digital. So the government are understanding the importance of the payment, that everything is no more physical, but is digital. Is like the last talk where you have seen the picture that is burning, and only is left the digital things. The money is going to be digital, and it's very dangerous that these things belongs to private companies and not to the people. This is the reason why something must be done.
Any questions for Professor Vespri? Question there?
Yes, there is a microphone.
Well, I'm quite loud, so hopefully this will be fine. So my question relates to the permission versus permissionless. My question relates to the permission versus permissionless ledgers. So I wanted to suggest that there are centralized system approaches, such as Xiaomi and Mints, for example, that can be very highly centralized, but still preserve the privacy within a measurable anonymity set for the users of the system. Have you considered that kind of design in terms of your consideration of anonymity as a requirement for the participants?
Yes, we were considering this. The problem that for some things people want to have absolutely idea of anonymity that only a permissionless can do, in the sense that permissioned, there are still something that, I don't know, can be checked in a certain sense, because there is always something that is looking. There is the possibility, even if they say there is not, people trust much more. It's something of people, what they are, the perception of the people. but people are trusting more in a permissionless than a permissioned. This is you must convince people that the permissioned guarantees the anonymity like that. It's also for the credit card. I was signing that they have not to give my information, and I am receiving the ad about the children book. So my sign was...
Because this is the level, let's say, required by law.
Yes.
And enforced by cryptography is a much higher level of, let's say, protection. But if you can create like a schema to protect anonymity with cryptography, would be much better than a legal requirement. Yeah, sure. We have another question from the...
Yeah, Stephen Ingberg. My question to you is, it seems to me that the discussion going on right now in between the EU digital wallet and CDBCs is mostly about identity linked to CDBCs. I mean, ECB discussing about digital wallet, digital euro, will be required to go through a bank, and thereby the identity in the banks needs to be questioned, because that will enforce centralized surveillance in the banks. So it doesn't really matter what kind of blockchain you use in the CDBC if you add identity on it afterwards. Or what do you have to say to that?
I think that to make the identification to the bank is, there are several problems, in the sense that I was considering this in the paper with Andrea, in the sense that it's clear that it should be only an infrastructure, in the sense that the bank should go to this infrastructure, because the government cannot take the work of the banks or other things. But the infrastructure, what is guaranteeing these things, should be, I think, is very important that is not private. It should be essentially. The second thing about this connection of these things is clear that when you have a permissioned, you can have a wallet where all your payments are made in the wallet. It's clear that everything is referred to you. When you have a permissionless, any payment is a different question, it's different things. So you cannot, so it's very convenient, very easy technologically make this. With the wallet, it's clear that you can connect with the banks. In the sense you are renouncing to the anonymity, and you can do this. When you want to have pure anonymity, you must have cryptography, you must have a lot of things to defend yourself.
This will be a long discussion in the next panel, so in the interest of time, we have a couple of talks more.
So, thank you, Professor Vespri. And let's move forward to the next contribution. Yeah, we have at the speech corner, forgive me my pronunciation, Gunit Kaur, okay, which is editor at Cointelegraph and a PhD candidate for professional doctorate in data science at the University of Stirling. The title of the contribution is Central Bank Digital Currencies, a New Generation of Digital Cash. The floor is yours.
Thank you for the introduction and the opportunity to present today. So today I'll be discussing an overview of CBDC developments in the UK, Europe, and China, and the global trends influencing CBDC's adoption, various perspectives on CBDCs and the benefits and risks of CBDCs, and a comparison of the three digital central bank digital currencies in the said countries, and historical instances post global financial crisis versus CBDCs, as well as a little explanation on anonymity levels of digital pound, digital euro, and yuan. So according to Bank of International Settlements Committee on Payments and Market Infrastructure. A CBDC is characterized as digital currency issued by a central bank, denominated in the national unit of account, and it signifies a liability on the part of central bank. This type of CBDC is meant for general purpose use, that is to be used by the retail customers rather than wholesale entities. And talking about the progress on these digital currencies, the Bank of England has completed a consultation phase with the consideration regarding its future introduction. And the digital pound will be designed for everyday payments, both in-store and online. Similarly, the European Central Bank has started preparing for a potential digital euro, and it is intended for all digital payments offering high privacy. However, China's digital yuan has seen rapid expansion with many wallets opened and high transaction volume. As of June 2023, 120 million wallets have been signed up for, with $1.6 trillion transactions happened using digital yuan. It offers unique features like offline transactions without a phone or internet connection. So what trends basically influence CBDC's adoption? Of course, the first one will be the decline in cash usage during COVID-19 and post-COVID-19 era. And the other reason is rise of privately issued digital assets, for example, Bitcoin, Ethereum, and various others. According to CoinMarketCap, which is the data provider for cryptocurrencies, there are 23K privately issued digital assets as of yesterday, with this number being only 7 almost a decade ago. And perception of central banks as lagging in payment innovation is another trend that influences CBDC adoption, followed by increasingly global payment systems. And the Bank of England sees digital pound as a catalyst for innovation in the payments ecosystem. Similarly, the ECB's main motivation behind digital euro is to promote innovation in domestic payments. And the Public Bank of China aims to regain control over domestic financial crime and protect national security via the CBDC. There are many diverse perspectives on CBDCs, both positive and negative. Some think that the design of central bank digital currencies is a global effort of collaboration rather than competition, whereas some people are totally against it, considering the various privacy issues posed by central bank digital currencies. So these kind of diverse perspectives on CBDCs lead to various benefits and risks that CBDCs might have to offer. So the key benefits of CBDCs include integrity and liquidity. So CBDCs offer the opportunity to central banks to ensure that there is a huge liquidity, as well as to protect the illegal generation or creation of fiat currencies. I think according to Bank of England's recent data, 1 in 30K banknotes in the UK are illegally created. Although the number is relatively very low, but the Bank of England still wants to tackle that using CBDCs. Also, according to central banks, the CBDCs will be designed with public interest in mind, and to ensure that it opens payment platforms and a competitive level playing field and the innovation of payments. Also, CBDCs aim to improve cross-border payments and limit the risk of currency substitution, followed by data governance. But of course, it requires careful data governance to prevent negative outcomes like market power abuse. In general, central banks closely regulate and monitor the use of liabilities, that is physical currency and reserves, to maintain control over monetary policy and ensure financial stability. As a result, Central banks might utilize CBDC's data for monitoring financial transactions, curbing privacy in transactions, increased surveillance risks, and also undermining confidentiality. So here is a quick comparison between digital pound, digital euro, and yuan. So of course, jurisdiction-wise, digital pound will be limited to UK, digital euro to euro area, and the yuan to China. So in terms of the use case, digital pound will be available for retail users, and whereas the other two will be available for retail as well as wholesale purposes. In terms of anonymity, digital pound will not be anonymous, whereas both digital euro and digital yuan offers anonymity for small amounts only. In terms of the transaction limits, there is a transaction limit of 10K to 20K GBP per individual for digital pound, and between 3K to 4K for digital euros per capita. And the lowest wallet is available for sign up without a Chinese identity card, which has an RMB 5K daily and 50K yearly spending limit. So the imposition of transactional limits within central bank digital currencies echoes historical instances post-financial crisis. For instance, following the 2008 global financial crisis, regulatory bodies increased oversight and imposed transaction limits on traditional financial instruments. Basically, taking example of Greek debt crisis, in June 2015, various banks in Greece imposed withdrawal limit of up to 60 euros per day, impacting freedom of people to use their cash as well as international transfers. So the various anonymity levels of digital pound, digital euro, and yuan versus privacy acts. So considering that Data Protection Act 2018 and GDPR applies to digital pound, so a potential violation scenario will be when a user's entire transaction history devoid of anonymity is tracked and stored without their explicit consent. So this kind of recording of data might potentially violate GDPR's principles on data minimization and right to be forgotten, as users might not have adequate control over their financial data storage and users. Similarly, in terms of the digital euro, if larger transactions lack anonymity, allowing extensive monitoring and profiling without explicit consent, this kind of scenario might also result into breaching GDPR's provisions on data protection and individuals' right to object to automated processing, ultimately impacting users' control over their transactional data's use without their consent. And in terms of the digital yuan, personal information protection law applies in terms of privacy, and similar to digital euro, if larger transactions face stringent monitoring without explicit consent, which has already been disclosed by Public Bank of China that they will be monitoring the larger transactions for financial crime purposes. So this might also violate PIPL's principles on data protection, compromising users' rights to financial privacy and control over their information. So here I did just a quick comparison of CBDCs, cash, bank deposits, third-party payment platform, and a decentralized currency, Bitcoin. So, of course, in terms of the form, they all are digital except that cash is a physical currency. In terms of debtor, for CBDCs, it's central bank. For cash, it's the holder. For bank deposit, commercial banks. And for third-party payment platform, it's particular to a particular payment platform. For example, for Alipay, it will be Alipay only. And in terms of the Bitcoin, as we all know that it's a decentralized, so the decentralized network is the debtor in that case. In terms of the credit risk, it's low in case of CBDCs and third-party payments, and no risk to none in terms of cash, bank deposits, and Bitcoin. Of course, in terms of issuers, CBDCs will be issued by central bank, cash is government, bank deposits by commercial banks, third-party payment platform by the platform itself, and Bitcoin is a decentralized network. The source of value in case of CBDCs is central authority. For cash, it's government, and bank deposits will be commercial banks, and third-party platform and decentralized system in terms of Bitcoin. The very important aspect in terms of owner anonymity, CBDCs are controllable as central banks are considering centralized ledgers. For cash, the holders have full anonymity. For bank deposits, it varies from low to none. Third-party platform, of course, can be controlled by the platform itself. And for Bitcoin, it's variable depending upon the specific use cases. So I conclude that the introduction of CBDCs marks a revolutionary shift in the financial realm, especially in terms of the payment systems, yet various challenges persist, particularly concerning privacy and cryptographic solutions. So addressing these complexities requires a delicate balance between technological innovations, regulatory compliance, and user privacy rights, which needs further research to ensure that CBDCs evolve as a secure, efficient, and privacy-respecting financial tools. So as far as my research is concerned, and I think that there are various open problems that might be interested to explore in future. This includes to address conflicts between CBDC functionalities and stringent data protection regulations to safeguard user privacy, innovating encryption methods to securely manage and store user transaction data, ensuring compliance and privacy, as well as addressing metadata vulnerabilities in CBDC's transactions, which is also relatively an unexplored area for future research. Thank you. That's all from me.
So probably, thank you very much. Probably we can just keep questions because now we are pretty tight on schedule, and also most of the questions that probably you want to address now will be also discussed during the next part of the session, where we will have like the debate and will be moderated by Andrea Bracciali. So I would take 5 minutes. I'm sorry, there is another contribution, of course. We have a video because the last speaker unfortunately couldn't make this event because of a health problem. So he sent apologies, also apologies because he also missed the dinner yesterday. And Professor Daniel Broby, which is Professor of Financial Technology at Ulster University. And so will be a video streamed, okay? The title of the contribution is The Policy Issues for Lawmakers, Central Bank Digital Currencies. So please. Let's play the video.
Hello, my name is Professor Daniel Broby, and unfortunately I can't be with you because I have a bad back at the moment. I was planning to come, but unfortunately you're going to have to make do with this presentation. What I'll do is I will try to keep it short so that essentially you have more time for discussion, and I would like you to consider what policy things need to be put in place to effectively enable digital currency in the future. So when I say digital currency, I'm going to talk from a general perspective of both wholesale and retail central bank digital currencies, but also digital payment platforms and stablecoins. It's my personal view that stablecoins are underrated in as much as they provide a middle ground between the issuance of retail CBDCs by a central bank and effectively sponsored digital fiat money by banks or financial institutions, which I think will probably increase in importance going forward and in some extent could even eclipse the even necessity for a retail central bank digital currency. But as I said, that's my view. That said, if you do go down the route of a central bank digital currency for retail, then you have to address something such as the legal tender status of that unit. Indeed, the legal tender status for crypto assets and or stablecoins, which is currently ambiguous to say the least. So a central bank digital currency, as you all know, is a digital version of fiat money. But what does that mean? It means that they represent an electronic liability of a central bank and fulfill these other functions, payments, transfers, and store of value. The debate is very much whether they should be token or account-based. In that respect, a number of different approaches have been tested. And again, you probably know the testing on the wholesale market, Project Helvita and so forth, as well as the testing in the retail market, largely done in China, the ECNY, which I have looked at in a research paper that has just been published. Importantly, if you're talking about implications from a policy perspective, obviously we all want to maintain the highest regulatory standards and we want to promote openness. In respect of competitiveness, we're in a very innovative environment. So I would add promote competitiveness. This is probably something which doesn't sit very well with a state-sponsored currency. But obviously we're in a world where there is competitiveness with stablecoins, with crypto assets, and therefore we need to consider how these fit into the equation. In that consideration, fair and proportionate regulations have to be considered. So, for example, the EU has currently got a consultation currently out on the sort of fines that can be imposed on digital asset providers should they sort of effectively misrepresent or do something that in the promotion that doesn't fit with the regulations. The question there remains, is this fair and proportionate? Because we need to obviously ensure that, for example, in this instance, focusing and making tough fines on crypto assets also does the same on stablecoins, which would mean that obviously there's less incentive for banks and financial institutions to promote those. So we need to understand these distinctions in order to create the playing field that we want to support and engender. Likewise, this is an area where payments is essentially almost 2% of global GDP. It's what makes capitalism, or even any other system, work for that matter. Now, in that respect, CBDCs, you could say, already exist. I mean, the payments are digital, and we do have real-time gross settlement with certain wholesale transactions. So the debate is focusing on where we're moving to, for example, atomic payment, and that atomic payment in terms of doing things instantaneously, counterpart to counterpart, gets rid of counterpart risk. And that obviously is quite an interesting concept to build into money, so to speak. And the other thing you can build into money is smart contracts. And again, if we're going to allow smart contracts to be built into something as important as how we store money, how we transfer money, we need to be sure that that is thought about at the policy level so that we're not reactive to something that has gone wrong because of something that has been programmed into that money at some stage. And also compliance and data issues that need to be addressed. So the playing field that I mentioned is very complex at the moment. We have payment methods and we have this divide between what is state-sponsored and what is decentralized, what is wholesale and what is retail. And from that, we have a whole range of digital payment platforms, whether it's between the banks, individuals, and or alternative methods themselves. So from a policy perspective, what you have is you have this very complex matrix of interactions that is currently poorly defined. And it's poorly defined from the perspective of what the implications are if things go wrong. And so there are three concerns in academia about what could potentially go wrong. There's the undermining of the efficient credit allocation, because effectively what we're doing is the central bank's balance sheets are more attractive than banks in the event that you can have effectively fiat currency sponsored by a central bank. And that obviously has financial stability issues because at a press of a button, you can move to safety, flight to quality. You can basically press money from a bank and directly to the central bank and thereby facilitate faster bank runs. And at the individual level, for the retail or whatever, there are a myriad of privacy and anonymity issues that I'm sure you are aware of. In terms of the credit allocation, central bank digital currency is a central bank liability. So in that respect, this distinction between wholesale and retail is important. The other thing that we have to understand is that obviously it's not the only central bank liability. And there are obviously many at the moment central bank liabilities. So all the concerns that are moved to CBDCs will destabilize the system, have to be put in context. So again, we can learn that from China, where we already have a legally recognized retail CBDC, the ECNY. In terms of just the outstanding M0 money supply, 9.6 trillion renminbi, relative to outstanding transactions of 83 billion renminbi in the digital space. So clearly not enough, even though this has been rolled out, not enough to destabilize the economy. But obviously the concerns about financial stability do exist, and mostly because the central bank is risk-free and therefore is seen as more attractive as a depositor than a bank. And so in that respect, how do we address that? Well, the literature has suggested that one way to address it is to have differential interest rates between essentially wholesale and retail CBDCs and or central bank deposits and what the CBDC itself would carry. And in fact, most of the consensus thinking is that maybe the CBDC should not carry an interest rate at all and therefore be more like cash in hand in its functionality. There are the privacy issues as well, and again we can learn from China there. So China is sometimes obviously criticized for privacy issues, and quite rightly so, but in terms of digital money and in terms of CBDCs, they have actually done a fair amount. They did introduce a national cryptography law to ensure that the protection was there for the CBDC as enshrined in law. And they effectively also have comprehensive national level data protection. In fact, they also introduced a personal data protection in the form of Personal Information Protection Law in 2001, which is pretty similar to the GDPR. So it's very easy sometimes to criticize, but there's whether the rule of law is upheld is a different question from whether the laws exist to protect effectively people using such instruments. And what is important is that they have put in checks and balances, and we need to do the same from the point of view of our central banks. Our central banks are currently very much in a debate as to should we or shouldn't we, whereas in fact they should also be thinking from that debate is, if we do, then what? And that then what should include what checks and balances should we put in place. So that leads us to the policy recommendations, which, as I said, feel free to discuss after this short video. So clearly what we learned from China is that you need to recognize in law a CBDC if it's a retail offering. You need to better classify in terms of the rights and obligations of ownership. And in the UK, we're doing this. We are introducing, on a recommendation of the Law Commission, a new class of property, namely digital assets. And this is very important because it means that essentially transfer ownership and the sort of where possession and so forth falls is very relevant to the future of what's going to happen with digital assets. And that obviously is equally relevant for CBDCs. Clearly, if we are going to change the law, we need to differentiate between retail and wholesale level at the sort of law perspective, the law level. And we also need to then address the fact that we haven't really clearly defined this distinction between what decentralized and what centralized actually is. So in that respect, if we are going to do this, what we need to do is we've got to make sure that privacy backs up trust. Banking is all about trust. Accepting a fiat currency is all about trust. In fact, if you look at the US dollar, it actually has written in it, "In God we trust." So in that respect, we need to enshrine in the legislation something that will give people confidence that this digital asset that they will have will remain their digital asset unless they transfer it legally to another party. We've also learned from China that there needs to be a testing environment, and that testing environment should be protected from unnecessarily regulatory burdens in much the same way that we do with our sandboxes in terms of trying out new fintech innovations. We need to do the same for how we test CBDCs. We also need to put thought to the national digital infrastructure. Essentially, if you're talking about people's money, you don't want to have a situation where the infrastructure fails, you can't make a payment, or where worst comes to worse, your server goes down and you need to have a disaster recovery plan on that. So we need to have a very robust digital infrastructure. Now, the telecom infrastructure is robust, but on the other hand, it is and can be improved upon, and obviously you don't want to go down when it's your money that's at stake. As I said, in terms of the financial stability, we need to decide, or central banks need to decide, like the Consol needs to decide whether or not a retail CBDC would be interest-bearing, and then what the policy are in place to determine that. So there would need to be for example, separate policy decision when setting the policy rate for digital money as opposed to the money for banks putting money on deposit directly with the central bank. There would also need to be effectively in the law that gives this legal recognition to the CBDC, essentially a reference to its roles in terms of its medium of exchange and its exchange mechanism. And in that respect, it's got to do that in a technology agnostic way. And again, coming back to the UK and what we're doing in the UK with regards to this new class of property in law, we have had to write it very carefully in terms of the way that it is technology agnostic as to the future direction of the way that digital transfers will occur. We also need to think about the delegated powers, so delegated powers of regulation, of oversight, and so forth, and that obviously needs to be enshrined in law, and as I'm sure many of you will agree, a degree of independence is obviously preferable in that respect. Imagine a situation where an oversight body could effectively cancel digital money, which you could do at the touch of a button. Obviously, that doesn't engender trust. So that's why it's necessarily to ensure that the delegated powers have a degree of independence. I've talked about the fact that you can include smart programmability into digital currencies, but obviously that's not just a good thing to have in terms of the fact that we can automate things like settlements and so forth in the future, but it's also a dangerous thing to have. And therefore we need to think about how and when that ability can be added to such instruments. Crypto assets, cryptocurrencies aren't going to go away, so obviously if we're going to address this in law, we may as well address the ambiguity there between these various instruments. And then finally, we need to think in terms of how secure these assets are, because as we know, there are cybersecurity issues in a digital world in all aspects of everything we do, and will be more so when we actually have digital money. So we need to think through things like the zero trust approach, and also think through how the multi-layer defense strategy from a cybersecurity perspective works in terms of the CBDC infrastructure. So there you are. I've written 2 papers on this: central bank digital currencies, the policy implications, and also the lessons from China. And that's, as I said, just a basis for discussion. And once again, I'm very sorry that I couldn't be with you. And especially, I just received the invite for the dinner at the Marriott, and I'm very jealous. Thanks very much, and have a good discussion.
Okay, so Professor Broby, of course, cannot answer any question, but if you have any, feel free to contact me. I will be your proxy to Professor Broby. And then now I leave the floor to Andrea.
Yes, so what I would like to do now is a discussion, a panel. I would like to invite, we have 2 panelists, if you can come to the stage. We have an expert in payments and someone more on the legal side. And I will ask them to present themselves briefly shortly. If I can have the page, please. So what we are, our starting point is this page of the technical public document of the Bank of England, which has run a consultation recently in July, I think. And this is a concrete example of a concrete proposal, which is quite standard amongst the ones that I have seen. And I want to use it just to refresh what we are talking about. This is a public document. It's called a technical white paper. It can be found on the bank web pages, or you ask me. So the idea is the following. There is a ledger which is controlled by the bank. This ledger contains all the transactions, so provides finality, security, and so on and so forth. It's completely managed by the bank, and it is a top layer. As you can see, that there is a strong effort to make these things as similar as cash as possible, in a sense. The bank provides a technological layer of application programming interface APIs. So other institutions, public institution, private institution, can interact with this layer, for instance, for sending payments, transactions to be recorded through an interface that is provided, technological interface provided by the bank. There is a strong accent on the third layer, which is a layer of services providers, which should be an open market in principle. And these service providers could be, I would imagine, banks, but also big players, stakeholders, startups in principle. And they provide the interface towards the citizens. So what they do? What they do is basically they do KYC. They identify the citizens as someone who is right to receive the money, in a sense. And they do some check on who you are. For instance, there are discussions whether CDBC should be available to non-citizens, visitors, and these kind of things, and how. And then there is a kind of obfuscation at a certain point. So these people become anonymized in the ledger. So the claim would be that the ledger is made in a way that privacy is preserved. And then there are the users. They are receiving a small amount of simil cash. For instance, this currency doesn't give you any interest, like physical cash. And you should be, in principle, able to exchange it even if you are disconnected from the network. So it's a quite complex architecture. We will be discussing point to point following this structure. I think the digital euro is quite similar. Okay, so if I can ask you to introduce yourself, and I would like to start by identifying from your viewpoint which are the benefits of this infrastructure for the citizen and for the company, for the stakeholders, for the state, for the central bank, why we are trying to do this. Well, no, us. Why the banks, why there is such a big hype, why it is so important.
Oh, I'm sorry. So I'm Jeff Goodell from University College London. My focus is on socio-technical systems in financial services, and particularly the future of money and the future of payments, especially retail payments and the implications of the relationship between individuals and the state and businesses. So when I look at CBDC approaches such as the one that the Bank of England had developed, as well as the one that the ECB had developed, I'm really looking at it from the perspective of the emerging digital economy and the motivations that people have for, that central banks have for wanting to develop central bank digital currency. And I know that there have been many arguments that have been made about efficiency and about facilitating faster settlements and so on. I think that these are basically a distraction. The real motivation for CBDC is the rise of the digital economy and the decline of cash. Let's make no mistake, this is what we're talking about here. And the relationships between individuals and businesses and the state are fundamentally intermediated by the way that they interact with the economy and the restrictions on those interactions that exist, especially in the world of retail online payments, which right now are mostly governed by relationships with banks and bank accounts. So many of the systems that we've looked at over the last several talks have really been account-based systems, including the various efforts to build CBDCs in places like China. And
let's be really clear. If you have an account-based system, you cannot be private. Accounts fundamentally are about identifying yourself to some particular third party and making that identity, binding this identity to various different transactions that you make. So even if we follow a plan such as the Chinese digital renminbi, we'll see that the accounts, the different transactions that are made with an account are bound to each other. So even if we think about this as being a kind of a prepaid debit card, the fact that these transactions are linked to each other creates an identity, even if the name of the payer is not associated. So really, this system is not anonymous at all. Similarly, the approaches that have been proposed in with the digital euro are also linked to accounts fundamentally, and this is really problematic from the perspective of individuals. So we can talk about that, but I guess I want to really focus upon the motivations once again. We need a public payment option, and I think part of the reason that China and Europe and the US and other places are looking at this seriously is because we need a way for people to hold direct central bank obligations in order to conduct their ordinary commerce. Right now, with the rise of debit cards and bank accounts being involved with most of the retail transactions in many of these countries, we see that the value of actually exchanging bank account money, which is to say the casino chips, in the words of Brett Scott, that are issued by banks to execute their transactions, we actually see that people might not be able to convert their money into cash if cash doesn't exist. And we see this with the closing of bank branches in places like the UK and Sweden and so on. So basically, we need a system for a public payment option in order to give central banks a way of transmitting their monetary policy. And this is a really serious issue in the developing world in particular, where we see that the monetary policy transmission channels are eroded by the fact that individuals are really holding and using as money bank deposits rather than central bank obligations. So we can see why central banks might want to do this, but we also see the affordances for ordinary people when they want to use money. They want to actually own their own money, and many proposals such as this actually don't really allow individuals to own their own money because they are gated by intermediaries. And what we see here is that really, just as programmability introduces a problem because fundamentally we're imposing constraints on how money is used, and we can talk about that. I think we can see that the reason that people aren't concerned about the cash in their pockets actually having their value be destroyed is because central banks have a very strong motivation not to do that, right? Which is to say that you can't destroy my cash without destroying everyone else's cash at the same time. Whereas with account-based systems, individuals could potentially be singled out. Like if this were money in my bank account rather than cash, the bank could decide to shut me off, as we saw in Ottawa with the Canadian lorry drivers in February of last year, for example, right? And we have seen instances of bank access being weaponized in this way. I think we really need to take a step back and understand why people have bank accounts. And historically, this was the money creation process. They put in a deposit, their money earns interest, and their community gets investment in risky companies. But now we see that if you ask young people today why they have bank accounts, they'll just tell you, well, I want to buy things online, or I want to buy things from that coffee shop that doesn't take cash. And this is really interesting, because now all of a sudden we have a world in which we need banks to do something that really isn't about banking. So I think we need to ask the question, what is the difference between banking and payments? And should banks really get back to banking and not be focused on payment infrastructure? Thank you.
Well, it's my turn. I'm Giorgio Gasparri. I know I'm walking a line here because I'm a lawyer among mathematicians, engineers. I work here as a senior legal advisor to a board member, and I worked since 2005 here in Council in legal studies office. And I was a former professor at University Federico II in Naples. I know I'm walking a line here because I'm representing a surveillance authority, but our session separates us from a very well-deserved meal, so we have a responsibility to sum up and to come to a point. So I try to sketch some reason why we could have a digital euro or a digital pound, and some reasons why we might not have a digital euro or a digital pound. So the idea of a digital euro has aroused, as we have said, much interest and discussion across Europe. While there are challenges to be met, we have here about these challenges, there are also many valid reasons why, at the end of the preparatory phase that we have started, the Digital Euro initiative could actually be launched. Among them, we have 8 points. The first point is the digitization of the economy. The global economy is becoming increasingly digital. A digital euro could place Europe at the forefront of this transformation, facilitating faster, safer, and more efficient transactions. Secondly, this would be a response to the growth of cryptocurrencies that we have seen. With the increasing use and popularity of cryptocurrencies, a digital euro could offer an official, a public, and regulated response to this trend, providing greater stability and trust compared with the other private cryptocurrencies. Third, greater financial inclusion. So the digital euro or the digital pound could facilitate access to financial services for those currently excluded from the traditional banking system, promoting greater financial inclusion. Four, we could have a reduced cost associated with cash handling. Digital transaction could significantly reduce the cost associated with the printing, distribution, and handling of physical banknotes. Also the risk of robbing and also. This, of course, does not mean that the digital euro, if effectively launched, or the digital pound, will replace cash, to which it therefore stands as a mere complementary tool. 5, innovation. Innovation and competitiveness. The adoption of a digital currency, a CBDC, a retail CBDC, could stimulate innovation in the financial and technological sector, strengthening Europe's position as a leader in the global digital landscape, so against China and US, I think. 6, interoperability with other digital systems. The digital euro or the digital pound could be designed to work seamlessly with other digital systems and platforms, facilitating cross-border transaction and international cooperation. 7, demand response. If a strong public demand for a digital currency is discovered during the preparatory phase we are facing, this could be a strong incentive to proceed with the launch. 8, and last for the pros, security and resilience. With the adoption of advanced technologies, the digital euro or the digital pound could offer a more secure and resilient payment system than traditional methods, reducing the risk of fraud and attacks. But the adoption of a digital currency by a central bank is a revolutionary step with many challenges and considerations. Despite the growing enthusiasm and interest, the hype, there are several reasons why, at the end of this phase, the digital euro initiative might not be launched. First of all, there are privacy concerns. The privacy of citizens is a major concern. It's the first concern in the interviews of the people interested in this field. If it's not possible to ensure that transactions and user data remain private and secure, this could hinder the adoption of the digital euro, the digital pound. Second, financial stability. The introduction of a new form of currency could have significant implications for financial stability. If there were concerns that digital euro could destabilize the European financial system, this could delay or even halt its launch. Third, insufficiently resilient technology. The technology behind the digital euro or the digital pound must be robust and secure. It's safe and sound, as we always said. If during the preparatory phase technological problems or vulnerabilities emerge, this could delay or halt the adoption or stop this adoption. The security of transaction and user data is crucial. Its concerns about the security of the digital euro or the digital pound will emerge, this could halt its launch. 4. Resistance of commercial banks. Banks may be resistant to the introduction of digital euro if they see it as a threat. It is a threat to their traditional business models and for their funding and for their purposes in the market. 5, so they will need incentives to participate in this model. 5, regulatory concerns. These are my preference. The regulation of digital currencies is still under development in many jurisdictions, including the European Union, as we have outlined above. If regulatory or legal concerns emerge, this could hinder the adoption of the digital euro or the digital pound. 6, public acceptance. This is crucial. To be successful, the digital euros must be widely accepted by the public. If during this phase it turns out that there is significant public resistance or skepticism, this could influence the decision to proceed, because people may think, why? I have a card, I need a second to pay my goods, instead of make a photo of a code and then make some operations. It may need 5 seconds, better 1 second than 5 seconds. 7, implementation costs. The creation and distribution of a new form of currency entail significant cost. I know that in UK this is a problem. No? Also the analysis of the digital pound pose some cost problems, some cost issues. If the costs exceed the expected benefits, this could be a deterrent factor. 8, and last, interoperability with other systems and competition issues. The digital euro should ideally work smoothly with other financial and technological systems. If there were interoperability problems, this could be an obstacle. Should other digital currencies, whether of central banks or private entities, gain a significant market share, this could reduce the attractiveness of the digital euro or the digital pound.
Thank you very much. Before giving the floor the possibility of asking a couple of questions, I would like to very briefly, if you want, comment on 3 features that are trying to make the digital euro pound similar to cash, or in the technical usage, which are, if you have any opinion on this, this is relevant, no interest, limited amount that people can have, And this idea that can be exchangeable even if you are not connected to the network, which is a very difficult technically problem to be solved offline. So can you make a very brief comment before we take some questions on these 3 points, again, which are no interest, limited amount, offline?
Sure, happy to begin. Yeah. Thank you, Andrea. So when I think about no interest, my first thought is, well, why do we have interest on bank deposits in general? And the reason is that this is the credit creation process. This is the process by which money is made. It's an economic process. What are banks really? Banks are institutions that take deposits and they make risky investments. I'm not talking about central banks here. I'm talking about private sector banks. Central banks can't make risky investments, and that's really important to note. Now, when you're investing in a commercial bank, when you make a deposit, that money is now available for that commercial bank to take risks. Now, how the bank manages its risk is its business, but fundamentally, the idea is that it's going to invest in a pool of different kinds of instruments. It will invest in businesses, perhaps, or maybe mortgage loans. Maybe it will make bank loans to individuals or businesses, and so on. But the reason that we have interest is because those loans are risky and they carry interest. And what flows back to depositors is a fraction of the returns from those investments. Now, if we talk about central banks aren't in a position to make risky investments. They cannot do this. So when I think about no interest, if it's a central bank asset, it doesn't make sense to me that there would be interest at all if we treat this as if it were a bank deposit. That doesn't make sense. Now, that's not to say that we could not have a system where we use CBDC to implement fiscal stimulus payments to holders of digital tokens. That's entirely possible to do, but I don't think that that's really the question here. I think this question is about the role of CBDC, and the role is not to replace bank deposits. The role is to facilitate payments, and for this reason, I don't think that this no interest question is problematic at all. I would expect that it would earn no interest because this is its role. It's not a replacement for bank deposits. Now, the limited amount, that's a bit of a concern to me, because the justification, if you look at the consultation papers for the digital pound and the digital euro, you'll see that they justify their restrictions on wallet sizes as saying they want to prevent bank runs. But this is very strange, because really, if you want to limit bank runs, you'll do what we saw in the earlier presentations from Greece, limiting withdrawals from ATMs or banks. If you want to limit bank runs, you can limit the withdrawals directly. You don't need to be limiting the amount of money that people can have. And in fact, limiting the amount of money that people can have, not only is it not necessary, it's also not sufficient. If you have some kind of an upper limit that's reasonable and everyone suddenly makes a withdrawal towards that upper limit, this could lead to a bank run every bit as much as it could if this were not limited. So I think that this is very strange that they've taken this approach, and it's very poorly justified in these papers. And finally, when we talk about offline, what I can tell you from my work in standards development is that in many cases the proponents of offline payment requirements actually are hardware manufacturers who want to ensure that there are certified hardware requirements that get built into the development of digital wallets and the rules surrounding digital wallets. This would be a really big mistake. It would be a big mistake not only because it preferences their business models and actually creates something that's not so public, but it also is a mistake because it curtails innovation. If people can't develop open source wallets that can hold digital assets, then people won't be able to really own their own money. And in fact, they're subject to the restrictions that their devices make upon what they can do. And I would go further to say that if we have rules concerning what wallets are accepted or not, or registered or not, and identified, this will break their privacy, or potentially break their privacy, and it will also prevent them from designing their own wallets, which is an instrumental part of the innovation process that allows them to know that, that the money that they're actually holding is theirs. So I'm very concerned about this, this offline payment requirement, and I'm also a bit mystified in the digital euro consultation and the single currency package, why it was stated that for online payments, we get a degree of privacy that is comparable to online payments with bank cards, which, by the way, is zero privacy, let's be really clear. And for offline payments, you would have something similar for cash. The reality is that we're missing the whole purpose of CBDC. The point of CBDC is to allow a public payment option in the digital economy. The reason that we're motivated to be here today to talking about this is precisely because of online payments that are taking place both over the internet and at the point of sale via EMV terminals. That's what this is about, nothing more. So when we talk about offline payments as a requirement, I'm not so sure that this is that this makes a lot of sense. If we want an offline payment that's robust, you can't beat this, and it works quite well. Now, yes, China is right when they say that there are costs of distributing this and deploying this, but this will never go away because there will always be people on the edges who aren't going to have immediate access to facilities to withdraw tokens and engage with banks and so on. We will always have this in some form or another. So if we think about the requirement for offline payments as really being analogous to the requirement for where this will be necessary, I think we'll very quickly find that the issue with CBDC is about online payments and precisely about the requirement that one of these parties is able to connect. It might be disconnected from the internet, but needs to be a third party in order to have fair exchange, as Roberto Paglia showed us in 1999. So I think we're misplacing our focus. Thank you.
Thank you very much. I think these three are hot topics. Interest rate. Well, the digital euro will not be an investment product. This is the sense of the deny the interest rate. And it's a simple mean of payments to complement the banknotes. And there is another motivation that have led to this choice of not recognize, not acknowledge interest to the bank, to the deposit of this digital euro. The sense is not to crowd out the intermediaries, not to create a difficulty to the funding of the intermediaries. So I think that these are good reasons to not recognize an interest rate, not to create a competition between bank deposits and a wallet with digital euros. Second topic, the limited amount. I think there is a misunderstanding about this topic because there are two kinds of limitation. The detention limitation and the transaction limitation. So we can recognize that, as you've mentioned, this is quite difficult to understand why we are talking about 1,000 in a first phase limitation of detention, and in perspective 3,000 of digital euros limitation. While in UK they're talking about 10,000 or 20,000 pounds, but there is no agree about this sum. Then we have the difference between the limitation of transaction. The limitation of transaction make more sense because it's linked to anti-money laundering issues, counterfeit of terrorism, avoiding crime and the corruption issues. So maybe I could agree that the detention limitation must be augmented because the risk of crowd out the intermediaries, I think it's very low, because I don't think, as some ECB director said, that digital euro we have a lot of success. It may be have a success, but not too much success. That is what ECB wants, that digital euro have not too much success, so the system could scale up very gradually. So the third point is very interesting, and the offline payments, and puts the question about the sense, the really sense of the very sense of this creation, of the issuance of a digital euro. Well, I agree. The issue linked to less privacy in transaction above some cap, and the less in case of lower transaction may create some difficulties in comprehension, because it may lead to the consideration that under a cap there is tolerance in front of little corruption, little crimes, buying of substance. That is a problem of credibility of this kind of limitation of transaction data to ECB. But as my colleague have mentioned, there always be the cash. So the banknotes will always overcome these problems. So I think the offline transaction issues are very more linked to the technological issues, because we need some softwares and hardware mechanisms that avoid the double spend issue. So we may have problems linked to this kind of technological advances, to avoid an undesired outcome of this kind of transaction, which have more privacy, but can jeopardize all the system in the phase of the settlement, you know?
Okay, I think it's a good moment for questions or comments, if you have any, or curiosity, or Davide, there is one in the front, so we go. Conscious of time and lunch, please, brief questions to the point. You have to press a bit, keep pressing until it goes on.
Very quick question. So, as a citizen, my first concern will be two very simple questions. So, in your opinion, should the digital euro allow to reduce transaction cost, like, for example, the one that now merchants are charged by Visa, MasterCard, so the debit and credit card? First question. And the second one, as Italian citizen, my question is, if I have to do a bank transfer today, which is Friday, and I want to receive that the receiver receive money on Saturday, in your opinion, this is something that the digital euro could enable? Because people have a very, very simple concern. So it's a very simple question.
Let's take the next one as well. Davide, please.
I will be very brief about it. I think the reduction of cost is an issue because there are a lot of time a lot of implicit cost of this issuance. We are facing this question in years, and these years may cost some money. And we have competition costs that are inner costs. So we don't need to watch only the amount of rate of circulation of this kind of money. We have also to watch the whole system. And then we could make a balance between cost of the traditional system that will continue to live and that will adapt in an evolutionary sense to this new perspective. And then the other issue is quite more appealing, because I think it's now very time of 24/7 transaction in the digital universe, and we are not sure we want to leave all the sector to satisfy our people. We need to transfer this kind of payments in a public, secure, safe and sound sector with less intermediaries inside. So I think this could be a balance, interesting, in favor of the adoption of the digital euro, digital pound.
So I'm inclined to agree with my colleague's statement, first of all. But just very briefly, I think there is, if we look at the cost structure in existing payments that use EMV terminals and payment networks, we'll find that they're not zero, right? They're not zero to merchants. It acts like a tax. I think some people call this the card tax, if you will. The question here of whether we can do better than that really involves looking at where these costs are, right, and what they're for. Well, they're for credit and credit provision that's implicit to those transactions. So if the digital euro is implemented correctly, we could avoid credit provision and we could reduce those costs. And I think part of this is also a question about whether the EMV terminals and whether the card payment networks are actually efficient. And I think if we look at the fees structure for WeChat and Alipay in China, which are smaller by a factor of 10, I think it becomes very clear to see that we can be much more efficient technically, and we can also eliminate the use of credit. And I think if we do both of these things, I think it's pretty clear that there's an opportunity to reduce costs. Second, for the speed of transfers, I think that this really has to do with how it's implemented. If we implement this using a mechanism that allows people to hold their own assets outside of accounts and only commit records of having transferred it from one party to the next, it can be quite fast indeed, because it doesn't have to go through any kind of reconciliation or settlement process. So yes, I think that this is, there are opportunities, but it depends on how it's implemented. Thanks.
Next question, please.
Yeah, Stefan Engberg. I think CBDCs is an option, and there's good arguments for it, but I think I'm very scared of the way we're discussing it, because I think there's a lot of red herrings where we're focusing on small details, but there are much bigger issues at play here. Let me take 4 fast questions, and the question is, how do we address these? First, the biggest risk of a digital euro is not the discussion between the central bank and the private banks. It is that the digital euro will be used as a new way to finance EU, like we see in US, where they're just constantly devaluing currency in order to create larger and larger deficits. 1 question. 2 questions. Well, we're discussing digital euro as if it's about how fast we do payments, but we don't deal with the problem, which is, as Jeff said very clearly, is that the commercial payment system, the card payment system, has turned into surveillance mechanisms, feeding surveillance capitalism. We're not dealing with that problem at all, and that is a killer of EU economy. And people are just playing around doing nothing about that issue. Third, if we take out cash, which there's a lot of good arguments for, we have the basic problem is that we don't have any offline mechanisms at all. And that has turned the system extremely vulnerable. Fourth, Now, even though we do deal with the need for more anonymity or non-linkability in business to consumer, especially in the smaller amount, in the other end, we need much stronger security in terms of purpose-specific requirements when you do corporate, especially corporate cross-border payments, where the corporates are playing around with our economic systems because the protection against detecting what corporate do in one hand in one country, in one bank, is heavily linked to what the same corporate is doing in another country with another bank. Now, the question that I'm going to ask for you is, we can make a digital structure in such a way that we can put purpose-specific requirements to the transaction determined in a transaction that starts trustworthy, anonymous, and they say, according to this transaction, who is paying for what purpose to whom. We don't want to know who they are. We want to know what type of entity they are, for what type of purpose. That defines the kind of requirements that we need to put in place for secondary validations. But I don't see that kind of discussion. I mean, the question is, how do we raise the professional level of this discussion before we get killed by just this fast, well, it's cheap?
Okay, if you can skip privacy, that I want to make a comment and answer to the other three questions, please.
So starting at the top, digital euro is a new way to finance the EU. I'm not too worried about that because we can limit the issuance of the digital euro just in the same way that we can limit the issuance of cash. And if we create the right mechanisms, this would be a parallel process and might even involve the same supply chains. So I don't worry about that in particular. Second, how fast we, how we do payments and this idea of the surveillance capitalism angle. I think we can address some of that with the privacy question. Although I think that yes, you're right that this is that the role of the existing payments networks, and here I am talking about card payment networks in particular, although we can also talk about some of the closed-loop payment systems such as WeChat Pay, Alipay, and so on, and also bank transfers. Have we really deputized regulated financial intermediaries and these networks to become law enforcement, to provide law enforcement services? And I think the answer to that is yes. And I think that that is part of the reason that these kinds of mechanisms are not a good substitute for cash and are not actually affording their users the self-custody and privacy that they need to be able to really own their own money. Now, concerning the issue of removing cash, yes, I don't think that we can ever remove cash. And I'd like to point out that money existed long before central banks. Central banks are not the alpha and omega of money. It is what people use. There are examples of people using all sorts of commodities and all sorts of things. I understand that where Sam Bankman-Fried is in prison, they have a system that uses mackerel as money. People will create money. If we get rid of cash, all that we're doing is raising the costs of this economy. I don't think that we can pretend that we can just force people and corral them into a formal economy just because we want to do so. I think that if we go down that path, it's a mistake. And I don't think that that this is either useful or possible to achieve. Thank you.
Well, I think your question is very challenging. I may say that I agree with my colleague. I don't see the issue of financing the ECB balance with this kind of methods, because I think this kind of mechanism in the idea of ECB would be a less percentage of usability and of diffusion. So in the first years, there will be a lot of surveillance about this, and it would be a method of funding the euro balance. Secondary, you put a question, an issue about the capitalism and the competition between private and public sector. So the question is, do you prefer that our data are treated by a private sector that may also with limitation, treats that data for their own purposes, and we may agree with privacy agreements, or do you prefer this kind of data limited by law that are supervised by public surveillance systems, very safe and sound, are held by the public sector intended by the ECB inside a regulation very with no answer. But I think there is extremely posed this kind of binomium, because the private sector will not be crowded out by this kind of CBDCs, retail CBDCs. I think the ECB thinks about it like an experiment, a necessary experiment, but limited with its diffusion. And for the rest, I think my colleague said what I think also. So I agree with him. I think this is the same.
Okay. Last question before the lunch. So privacy, a bit more precisely. So if we look at this picture, we have the ledger on top, which is supposed to be anonymous. Identification is on the third layer, but there is the idea that if something goes wrong, for instance, for anti-money laundering or organized crime, there must be the possibility of going, I guess, opening the anonymized ledger and identify the culprit somehow. So how big is the problem in terms of privacy of having this big structure that is centrally controlled, that apparently has to be accessible for very good reasons, again, money laundering, crime, and all the rest, but of course poses problems of access, privacy, traceability, and the like. Is it a real problem? Yeah.
No, I think very briefly that we also in the question of the crowd, I think we have an elephant in the room, that is the risk of so-called digital authoritarianism by the public sector, by the ECB. So the fear of having a big brother that snoop all our transactions. Well, I think we have all the room for discussion, but the documents that are being diffused are very clear about all the limitation of the privacy issues. We European Union have a set of private data regulation that is up to date, that is future-proof, and about identification, and about know your customer issues, about anti-money laundering. We're up to date, I think. So I'm quite sure that the room of discussion are very limited about these issues. At least we have the room for discussion for a lot of years. So we may face this issue with academic, with lawyers, with legislators. There is no speed about it, I think.
So I want to address this by first referencing something that came up a very long time ago, about 55 years ago. A gentleman named Paul Armour, who was currently working at the Rand Corporation. He later went on to become director of a major computing lab at Stanford. He had delivered a deposition to the U.S. Senate, and he expressed concern that with the emerging digital payment mechanisms, he would not be able to purchase a newspaper or a candy bar, those were his exact words, without being exposed to the risk of profiling. And this was a big concern for him, but this was 55 years ago, so this is not new, but he saw this coming. I think when we look at this question of privacy, I think that it's exactly about this excluded middle, right? We see the existing world of card payments, which have zero privacy. And we also see this other extreme where payments take place perhaps using cryptocurrencies or other kinds of mechanisms completely in the dark and in an unregulated context, which is anonymous to be sure, but it's also not regulated. I think we're missing discussion about what problem we're really trying to solve, and there's an excluded middle here that I think we need to consider very carefully. What privacy do we need to sustain, and what things should be private and what things should not be private? I think that one of the questions from the audience concerned this need for accountability of businesses and corporate payments, and how we square this with the need for individuals who have the human right to privacy to conduct payments without the risk of being profiled, to make payments. Now, if we look at what the space of possible designs, we'll see that there are some designs that allow for payers to be anonymous, but recipients to be transparent. This design is a hallmark of David Chaum's system that he proposed in 1982 with his paper Blind Signatures for Untraceable Payments, and was later elaborated by projects such as GNU-Taylor and Project Tourbillon, which is the BIS Swiss Center project, which also has the same feature of privacy by design for payers, while still having transparencies and enforcement mechanisms for recipients of money. Now, I think if we look and take this model seriously, we'll see that with a model like this, we can enforce tax compliance, we can enforce sanctions for recipients of money, we can enforce withdrawal limits with AML KYC, and we can also provide anti-fraud mechanisms for consumers, all without exposing consumers to the risk of profiling on the basis of how they spend their money. I think that we need to consider this kind of model as a way to square the circle of making sure that consumers are not exposed to profiling, while also ensuring that there is an accountability for the transaction as enforced by the recipient. Now, let's be really clear. You can't trust what you can't verify, and if the data are ever exposed to a system, they're gone. So let's just accept Helen Nissenbaum's argument that that we've been focusing on the wrong thing when we're focusing on use regulation of data. We should be focusing on the collection instead. And that can be achieved with privacy-enhancing technologies, such as blind signatures and zero-knowledge proofs, if correctly deployed. And I want to close by saying that, that financial inclusion should not be about corralling people into mechanisms for monitoring their transactions so they can build credit. Let's be really clear. You can't offer someone the benefits of having accumulated credit without excluding someone else for not doing so. So if we're really focused on financial inclusion, we should be talking about how we enable people who do not have bank accounts or relationships with institutions to be able to engage in the digital economy, have something cash-like. And that means meeting them where they are and not attempting to outfit them with mobile phones or fancy payment cards. It really means enabling them to own their own money and to create a system for transacting that draws them in by giving them the assurance that they will not be profiled by design, not by promise. Thank you.
Okay, I think we are ready for lunch. I want really to thank our panelists for their availability, clarity, interesting insights. and the technical support for flipping all our slides. Thank you. And you for attending so far late. Thank you.